Hello everyone. Today we are doing mathematics paper 2, so math paper 2 from November 2023. Let's get into it. As always, important instructions: make sure your calculator's in degree mode, and every answer, final answer, is going to be rounded to 1 decimal place. You're going to see in the paper some places we're going to be working to 4 decimal places, or not even rounding during the calculations, but at the end always round to 1 decimal place. Okay, let's get started. Question 1, they say the percentage results obtained by 26 learners in a maths test is displayed in the box and whisker plot below. Okay, so very important, we got 26 learners, and let's have a look. So here's 40, this is our Q1, 59 is Q2, also known as our median, B is an unknown, A is an unknown. So A is our minimum, and 95 is our max, and B is our Q3, our third quartile. So these are the results. Now for question A1, over here for 1 mark, they say determine the value of A. Okay, for 1 mark. So they need this. But what's also important is they've given us some information here. They give us the range. They say the range is 80, and they give the interquartile range is 30. All right, so we need to know a bit of theory. You need to know that the range is max minus min. Okay, this is just something you should know and remember. So the range is maximum minus minimum. So we know that 95 minus A is 80. So you can almost just solve this using algebra. Sorry, 95 minus A is equal to 80. So then obviously that means that A is 15. And the IQR is 30, and remember the interquartile range comes from Q3 minus Q1, and that gives us 30. And our Q3 is B, and Q1 is 40, that gives us 30, so then that obviously means that B is 70. So you didn't actually have to show any calculations, or rather you didn't have to show any working, like I did here, but you didn't have to show any working, just the final answer. So let me just double check with that memo, 15 and 70. Yeah, so these could just be your final answers. This one and this one. Okay, let's move on to the next question. Determine the minimum result obtained using your answer A1. Oh, determine whether the minimum result obtained, that's what we've calculated, this A, this is the minimum, is an outlier or not, and then use this formula. Okay, so what we're going to do is we're going to say Q1, which is 40, minus 1,5 times IQR, the interquartile range, 30. And we're going to see what we get here. Okay, so if we do 40 minus 1.5 times 30, we get negative 5. Okay, so that means that if we get anything less than negative 5, then we'll have an outlier. Okay, but you can see here this A over here was 15 from the previous question. Okay, and you can see that 15 is bigger than negative 5. So then it's not an outlier. Okay, so you get a mark for this, and then you get a mark for saying not an outlier. Okay, now for question C, the table illustrates the approximate time spent in minutes. Over here, this is our X, by 7 learners studying for mathematics test, and their marks obtained as a percentage. Okay, so this is the information. Then they say predict using the equation of the least squares regression line in the form of this. This is all you really need to know. Don't worry about the regression stuff. And also, sorry if there's birds in the background. They're chirping and doing their thing back there. But I hope it's soothing. Well, then is annoying. Okay. There's always a lot of background noise with me, so I apologize. But so we got that form, and they say what we need to predict what mark a learner who studies for 180 minutes will obtain. Okay. Round your answer to 3 decimal places. So this is what we have to do first. We have to first get this equation over here. So what we're going to do is we just put our calculator in stats mode, and then we will be sorted. So we go mode 3 for stat, and you can see number 2 over here. You won't be able to see this. Let me do this. Okay, here we go. So you go mode 3, number 2, is a plus bx, which is exactly what we have over here, and it allows for an x and a y. Okay, so we get 0, 90, 90, 80, 90, 120, 150. Okay, so just make sure that that is 7, because there were 7 learners. Okay, then you can go back to the top. I like to fill it in like this: 59, 60, 73, 85, 90, 95. Okay, so you got all the data there. You can press AC now, everything's stored. And we need to find the A, so we go Shift 1 for stat over here, and we're dealing with regression. We press 5, press 1 for A, and this is our A over here. So I'm going to round it to 4 decimal places, so 2590. So it's 19,2590. Okay, so Y is equal to that, plus, now to find our B, what we do is we just go AC again, regression, there's our B, and our B is 5519. Okay, so 0,5519 x. Okay, so we're not done yet, because we actually need to use this, okay, use the equation to predict if someone studies for 180 minutes. Okay, but remember, this minutes is our x. So what we do now is we just put in a 180 over there. So what we can do is we could put these numbers in your calculator, but also an interesting thing, what we can do is we can do A plus, we go regression B times 180. So this will leave no rounding. Okay. So this is if you just use the values exactly without rounding. So I'm going to write this answer for us. It's 118,6. Okay, because remember, final answers to 1 decimal place. Oh, but they actually said to 3 decimal places. So 604. Okay, and then remember, the answer you get is as a percentage. So it should be this. Yes, they get 603. Very interesting. Okay, they get 603. Okay, so let's not worry too much about that. I'll explain in a second. But the thing is, look, this is a percentage. Okay, and you can't achieve more than 100% in high school, at least. In university, sometimes it is possible. But yeah, for the most part, you can't achieve more than 100%. So we have to say that the learner would obtain 100%. Okay, so the learner would obtain 100%. Learner would, let me change the screen so you guys can see me writing rather, would obtain 100%. Okay, so don't worry too much about this answer being different from the memo. The memo gets 603, but the main point is you get a mark here for the 100%. You don't actually get a mark for this. If you just put this final answer, you'll only get 2 out of 3. Okay, because you can't achieve more than a 100%. Kind of just like if, for example, we were dealing with people in this example, and you got 5,7, you would have to round to the nearest person. You can't say 5,7 people. It would have to be 6 people. So it's kind of like one of those things where you have to look at the actual data that you get and then interpret it. Okay, you can't just leave it as 118 over there. Okay, so don't worry too much about that rounding stuff over there. Now for question 2, they say, is your prediction a reliable one? Okay, and we need to say no for 2 reasons. All right, so the first reason is if we have a look, our time spent goes from 0 to 150. So this 180 over here is extrapolation. Okay, so we'd say no, it's not reliable because it is extrapolating. Okay, so I'm actually just going to copy what we get from the memo. It'll be easier than typing it out. So they say no. Okay, so you get a mark here for no. And what I was going to say here is 180 minutes is outside the data set, therefore it's extrapolation. So this word is important over here, extrapolation. Okay, then the second sentence that they have is quite an interesting one, but it says that it implies that anyone that studies over 180 minutes will get 100%, which is, it's not really a very valid explanation. So that's why it's not really reliable, but I'm pretty sure you don't even need the second sentence to get this explanation mark. I'm pretty sure if you just say it's extrapolation, then you get your 2 marks. Okay. So I hope everyone is happy with that. Let me make sure we're on the right screen. Yes, we are. Cool. Let us move over to the next question. Question 2, some geometry stuff. They say ABCD is a trapezium with AD parallel to BC. Let's see if they've given that. So AD parallel to BC, that's given, no problem. BCD is 90. Okay, let's not forget that. It's 90 over there. They give us the points A, B, C. They're given E is a point on that such that EC is equal to EA. So this is a midpoint over here. And we can work out the coordinates of this pretty easily because we have C and A over there. All right. Now they say determine the gradient of BC. Okay, so that's pretty easy. It's literally just plugging in values. So you can just say the gradient of BC is equal to, let's do 7 minus 4 over 6 minus 0. That's 3 over 6, which is 1 over 2. Okay, that's gradient of BC. But important, we just worked out this gradient, so we know this gradient. Okay, because the lines are parallel. Okay, I went way too far over there. Sorry about that. What I meant to do was erase this. Cool. So now they say determine the equation of line CD. So they want the equation of this line. So to determine equation of a line, you need a gradient and a point. All right. So first step, I keep doing this by accident, sorry. Here we are. Let me erase this. Okay. So we need a gradient and a point. So we need the gradient of CD. Okay, but very important, these lines are perpendicular. Okay, so we can immediately say that the gradient of CD is going to be the negative inverse of BC. So the negative inverse. So negative, and then 1 over 2 flipped is 2 over 1. Okay, so the gradient of CD is negative 2. You get a mark for just saying that. You could say that BC times the gradient of CD is equal to negative 1, and then this is a half. You could do all of that, but this is the only thing that's really necessary. Okay, so we don't really need all of that. Okay, so we have the gradient, and now we just substitute in a point. Okay, so for line CD, what we have is y is equal to mx. This is our gradient, mx plus c. Then to find our c, we just plug in a point, and we can plug in c over there. Okay, a lot of c's going on, don't let that confuse you. I hope you see what is happening. Okay, so what we can do is take that across. That's 12, so c is equal to 7 plus 12, 19. Yeah, okay. So don't leave your answer just like this, okay, because they want the equation of the line. Okay, so the equation you have to write in full, like this. This is the equation of line CD. Okay, if you just put this, you won't get a mark. You would only get, I think, 1 out of 2, to be honest. You need, okay, no, so once you substitute here, you get a mark for subbing, you get a mark there, and then for the final statement. So if you don't write the final statement, you only get 2. So don't forget that, okay, because I want the equation of the line. So give them the equation. Okay, now for B, they say determine the equation of AD. So we need the equation of this thing now, and hence the coordinates of D. So 2 steps over there. So first the equation of AD, and then the coordinates of D. Okay, so for AD, we have a point on the line. We just need to know the gradient of AD. But the thing is, we know the gradient because these are parallel. So the gradient here was 1 over 2. So we can say that, well, the gradient of AD is 1 over 2. And we don't even need a reason there. Okay, so we can sub a point. So We have y is equal to a half x plus c. We substitute a point. We're going to substitute for 1. So we get this plus c. And then if we solve for that, c is negative 1, right? Okay, so then for equation of AD, okay, so the equation of AD is y is equal to a half x minus 1. Okay, so that's the equation of AD. So we've done this part, and now they say hence. So using what we just did, we need to work out the coordinates of D over here. So we ask ourselves, what's special about D? So D is the point of intersection of this line and this line, of line CD and AD. So we know the equation of AD, and here we worked out the equation of CD. Okay, so then to find the point of intersection, we just set the lines equal to each other. So we're going to set AD is equal to CD. Here's CD. And now we're just going to solve for x. So we can take that 2 across, and that's 4 over 2. So this is 5 over 2x is equal to 20. We times both sides by 2. That's 40. Divide by 5 is 8. Okay, so x is 8. Am I correct? Yeah. So x is 8. But they want the coordinates of D, so we also need the y value. So what you can do is you can just take this 8 and you can put it in there, or you can put it in there. So the one on the left over here is probably easier. So to find the y, you say y is equal to a half 8 minus 1. So that's 4 minus 1, which is 3. Okay. So again, don't forget, state the coordinates of D explicitly. Don't just leave this x here and this y here. Okay, you have to put them together as a coordinate because you get a mark for this. Okay, so otherwise you would only get 4 out of 5 for this one. Okay, I hope everyone is doing well. I think I'm going a bit faster this time than normal, but I hope everyone can stick with me. Sometimes I go super slow because my mind, I just start going on a tangent, pun intended. Okay, and I'm starting one now, so let's continue. C. It's further given that point F is a point in the first quadrant such that FEDA is a parallelogram. Okay, so we have a parallelogram. So important quad theory over there, a parallelogram. The coordinates D are also given. Okay, so they gave us D. We already knew, because we worked it out correctly, we already knew what D was. Okay, let's add that information. 8.3. They tell us because we're probably going to need it. All right. So it's a parallelogram. So we know that FE is parallel to AD. Okay, they haven't even asked a question yet. But now they say determine the coordinates of F. Okay, let's see what we know about F. F is the point of intersection of line AF and FE. Do we need to work out those things? Let's have a think. So we can work out, we know that this is 8.3. Ah, yes. Okay, so I remember the memo did this in an interesting way. Where did the memo do this? They did this midpoint thing. I didn't really like, they did it in a very short way. I didn't really like it. Because then they get the midpoint of AE again, and then F is the midpoint. Okay, so I'll explain what the memo did. I'm going to do it a different way. So essentially what the memo did is they work out E, the coordinates of E. E is the midpoint of AC. Okay, so they work out E and they get E to be 5,4. Okay, that's the midpoint. Then what they do is they take the midpoint between EA, this point over here. Let's call it Q. So they work out Q. All right, and we can work out Q. So Q will have a value, and that will be 9 over 2 and 5 over 2. All right, and the thing is, what's interesting about Q, Q is the midpoint of FD. So now you can then use the midpoint, you can use midpoint theory again to then find F. Excuse me. So I don't really like that. And there's nothing wrong with that at all. It's quite a good solution. But for me, I like, for me, remembering, that's a bit of like parallelogram theory to remember. And I hate memorizing theory. So what I like to do is I would want to work out the equation of AF, the equation of EF, set them equal to each other because this is the point of intersection. Okay, so the first thing is I need to know what the equation of AF is. Equation of AF. All right. So I can find the equation. I just need the gradient of AF. And the thing is, I know the gradient of AF is going to be equal to the gradient of ED, because remember, this is a parallelogram. So the opposite sides are parallel. And then to find the equation of ED, I'm going to have to know E. Okay, because I can use then 2 points to find the equation of line ED. So I need to first start off by finding E. Okay, so E is going to be the midpoint of AC. So that's going to be 6 plus 4 over 2 and 7 plus 1 over 2. Okay, so E is given then as 5, 4. Okay, we already discussed that. So we have E. I'll fill it in for us. 5, 4. There's E. So what I can do now is I can work out the equation of this line. Okay, I can work out the equation of that line. Is there an easy way? No. So let's work out the gradient of ED, of line ED. It's going to be 4 minus 3 over 5 minus 8. So that's negative 1 over 3. Okay. So we can say therefore, we can say therefore the gradient of AF is equal to negative 1 over 3. Okay, so this way is a bit longer than the memo way, but I hope everyone's following. So now what we can do is we just substitute 1. So we're working with line AF now. It's good to label this. So we're working with that and we're substituting for 1. So we get this plus C. We take that to the other side. This is 4 over 3 plus that. So C is equal to 7 over 3. Okay, so the equation of line AF is this, plus 7 over 3. This is the equation of line AF. So that's our first step done. Now we just need the equation of EF. Okay. So, but we know that the gradient of EF is equal to the gradient of AD. Okay, and AD over here was 1 over 2, because this one was 1 over 2. It was the first thing we worked out over here. So it was actually an A. Yeah. So CD, no, it was even before this. Okay. It was this. We worked out BC is this thing over here. So BC is a half. This is a half. So then this is a half. Okay. So gradient of EF is a half. We substitute a point. We substitute E. So we're working with the line EF. Okay. We substitute E, so we get 4 is equal to 1 over 2, 5 plus C. So C in this case is 5 over 2, so 3 over 2. Yeah, C is 3 over 2. Okay. So the equation of line EF is y is equal to a half x plus 3 over 2. And now what we have to do is set this line equal to this line. So we get a half x plus 3 over 2 is equal to negative 1 over 3x plus 7 over 3. Okay, so what I can do is take this to this side. I'll show you how I would do it in the calculator. So we need to get out of stat mode here. So what I would do, let me move this. Over here, I'll move it over here. So what I'm going to say is 1 over 2 plus 1 over 3. Okay, it becomes a plus because it goes to the other side. It's 5 over 6. So 5 over 6x is equal to, and then what I'll do is 7 over 3 minus 3 over 2. And that's 5 over 6. Okay, so that's quite convenient. So obviously x is just 1. Okay, so x is 1. And then we substitute this back into one of these ones. Okay, we can either substitute it in this one or this one down here. So it's obviously easier this one on the right. So it'll be a half plus 3 over 2, which is then 2. Okay, so y is equal to 2. So then therefore the coordinates of f is 1, 2. Okay, that should agree with what the memo said. Let me confirm with the memo. Where's the memo? Yeah, f is the point 1, 2. Okay, so I'm going to put the memos working on the screen, just so if you want to pause and see the memos working, then this is the memos working over here in this block in the middle. Okay, I'm not going to go through that though. Okay, let's continue. Now they say determine EAD correct to 1 decimal place. So EAD. So this angle over here, EAD. So interesting question. Okay, so this is the analytical geometry section, and they're asking for an angle. So different ways you can approach it. The first thing I would think about is inclination. Okay, so the first thing I would think about is our inclination formula, which is this. It is tan theta is equal to m. And the reason I think about that is because theta is an angle. They're asking for an angle. M is for gradient, and we've worked out a bunch of gradients. Okay, so what's important though is they want this angle between these two lines. So what we're going to have to do is work out the inclination of AC and then subtract that from the inclination of AD. Okay, but remember D is 8.3. Okay, so we know that MAD, so the gradient of AD, we've worked it out before. This is a half. It's 1 over 2. Okay, so what we can do is we could call this theta 1. Okay, because what's happening is we're tracking this down here. How do I explain this? So let's just call it theta 1. Let me not draw it right now. Let's just say we work with theta 1. So we're going to say that tan of theta 1 is equal to 1 over 2. All right, then we use our calculator, make sure it's in degree mode, and we do shift tan of a half, and theta 1 is 26,565,5651 degrees. Okay, so here I'm working to 4 decimal places, but I will round my final answer to 1. Okay, I recommend working in the problem to 4 decimal places. So essentially what I've done here is if I track this down, this line AD, what I've worked out is this angle over here, and I've called it theta 1. Okay, so I've worked out this angle, theta 1. What I'm going to do now is I'm going to be looking at AC. So AC is going to be this larger angle over here, and I'm going to call that theta 2. Okay, so I'm going to be doing that step over there. And then you can see what the question asked though is this little thing over here. So what I have to do is theta 2 minus theta 1. Okay, so you're going to see where that comes about now. Okay, so this was my first step, theta 1. Now I need to find gradient AC. Okay, so gradient AC, I don't know if I've worked it out before, but we can do it quickly. Let me just get rid of this so I can see. That's 4, 1. So that'll be 7 minus 1 over 6 minus 4. Okay, so that's 6 over 2, which is 3. So that's gradient AC. So now I'm going to say tan theta 2 is equal to 3. And then theta 2 is equal to shift tan of 3. I get 71,5651 degrees. Okay, I'm not done yet because I need to be saying that angle EAD is theta 2 minus theta 1, which is the 71.5651 minus 26.5651, which is exactly 45 degrees. Nice. Okay, You don't really have to put 45,1. It's just 45 degrees. Okay. So a lot of students struggle with this inclination thing, but this is a thing you can remember. Okay. What you can do is you just take the inclination of this line minus the inclination of this line. Okay, so you're just subtracting these two angles to then get that angle over there. Okay, inclination. And we knew we were probably going to use this topic because we're in analytical geometry. Okay. Now, they say hence or otherwise determine the area of parallelogram ADEF. So ADEF, this thing over here. Okay, so we now know this angle. Okay, we know this angle, and we have to work out the area of the parallelogram. So what you'll notice is if we just look at this triangle over here, we know that D is 8, 3. We know that E is 5, 4. Yes, 5, 4. We worked that out as the midpoint before. So we know that. So what we can do is we can actually do this distance. Let me use a different color. We can work out distance AD, this distance over here, and work out this distance over here. And what we can do then is we can use the equation for the area of a triangle. Okay, so we're going to be saying that this is the formula we're going to be using the area of EAD, triangle EAD is equal to a half AE times by AD times by sine of the included angle, which is what we worked out in the previous step. Okay, so we're using the hence thing over here, which was sine EAD. Okay, so that looks not very good. It's going to be the little cap thing. Like that. Okay, so we can work out this and this using the distance formula. Okay, so let's do that. So AE is equal to the square root of, and then we're going to say 5 minus 4 squared plus 4 minus 1 squared. All of this is square rooted. So this is 1 plus 9, so it's the square root of 10. So it's 10 units. And then AD is equal to, what do we have there? 8 minus 4 squared plus 3 minus 1 squared. So that's 4 squared, 16 plus 2 squared, 4. So this is root 20, right? Root 20 units. Okay, now to work out the area of the triangle. Okay, let me just state why we're working out the area of this triangle. So they asked for the area of the parallelogram ADEF. Okay, but if I work out the area of this triangle, what I can do is I can just double it to then get the other triangle, which will be the whole parallelogram. Okay, probably should have started with that, but hopefully you guys stuck with me there. Okay, but anyways, let's work out the area of this triangle that I've colored in very beautifully in orange. Okay, so what I'm going to do is I'm going to repeat this equation. Let's just copy and paste. I know this looks terrible, but it saves me some time. Let's get rid of what we don't need here. This, and this. Okay, we're going to say a half AE is root 10. AD is root 20. Let me confirm it, the memo. Yeah. Was it root 20? 2 root 5. So it's 4 times. Yeah, okay. So everything's fine so far. And then sine, don't know where that went. Sine of the angle from the previous question is 45 degrees. So if we work that out, it's a half times the square root of 10 times by square root of 20 times by sine 45. So the area of one triangle is 5 units squared, square units. So we're not done. We need to say therefore area of parallelogram ADEF is 10 square units, 10 units squared. Okay, because it's just double this. Okay, it's just double. Okay, hope everyone was with me there. Here we have a frequency polygon. It represents the results obtained by 27 learners in a mathematics test. So that 27 could be useful. So don't forget that. And then they give the class intervals 0 to 20, 20, 40, 40, 60, 60, 80, 82, 100. Okay, so what you'll notice is here in the frequency polygon, we're plotting in the midpoint of the interval, because the interval is 0 to 20, but we plot in the middle. Okay, this is different from the ogive, where we would plot at the end of the class interval. Okay, that's just something to keep in mind. Okay, so remember your theory of how to draw an ogive. That's going to come up in a second. All right, they say determine the estimated mean of the set of results. Okay, so the estimated mean is used when you take the midpoint. Okay, that's when you use the midpoint. So essentially we're going to be using these values over here. You'll see in a second, it's not too complicated. So X bar, that's for average. And what we're going to do is we're going to say, well, the people that got 10, there was one person that got 10. Okay, so we're going to say 1 times 10. Okay, plus, then if we look at the people that got 30, there were 7. Okay, so we're going to then say 7 times 30. Okay, so what's essentially happening here is between 20 and 40, 7 people got marks between 20 and 40%. But to estimate it, what we do is we take the midpoint. Okay, because remember, we don't know. Someone could have got 21, someone could have got 22, someone could have got 39. So we just put it in the interval. Okay, but when we do the estimated mean, we can't get the exact mean because we don't have the values. We don't have the 21, the 39%, the 27, etc. So this is the estimate. So we're using the midpoint over here. Okay, so that explanation, I hope, makes, if you were confused of what's going on, I hope that kind of puts this into context if we think about it. Okay, then if we look at 50, 10 students got 50. Okay, 50% for our estimate. But again, remember that means between here, 10 students got that mark. Okay, plus 5 times 70 plus, and then this last one is 4 times 90. Okay, and we have to divide this over the total number of students, that 27. Okay, that's where it comes up. Okay, so what's important here is the frequency polygon is different from the ogive. The ogive is cumulative. Okay, so it adds. Okay, so you'll see in the ogive, I'll explain it over there rather than here, but what's this is different because if you have this 10 here and this 1 here, it means that one student got 10%. And then if you have this 7 over here and this 30, it means 7 students got 30. Okay, it doesn't mean that between here and here there was 6 students. Okay, you'll see once we get to the ogive. But over here it kind of just becomes plugging all this in your calculator. So 1 times 10 plus 7 times 30 plus 10 times 50 plus 5 times 70 plus 4 times 90 over 27. Before you press equals, have a think. Okay, what kind of value are you expecting, right? This is an average for a maths test. Okay, so okay, I don't want your mark or your feelings to push you and be like, okay, for the average for a math test, 0. Okay, let's not jump into hyperbole over here. Okay, if we look at this frequency polygon, most of the results are kind of like between here and here, 40 and 70. Okay, in the middle is kind of about 55. Okay, so when you press equals, you're expecting a value maybe around 50, either side of 50. Okay, you don't want to be expecting everyone getting 100% or people getting 10%, or if you're getting a negative number, you know you really messed up. Okay, so think about it and make sure your answer makes sense. Okay, maybe you added an extra 0 here if you get a really large number, for example. But what we end up getting is 52,96. Okay, that rounds to 53%. Okay, because remember to 1 decimal place. Okay, so the estimated mean for this is 53%. Okay, yeah, 53%. So if we move over, they say what percentage of learners obtained a result in the interval 60 to 80? Okay, here's our interval 60 to 80. Okay, but remember in that interval we plot only at the 70 mark. So between 60 and 80, we just plotted the 70 mark. So there were 5 students that got between 60 and 80. 60 and 80. There are 5 students that fall in this interval. Okay. There's 5 students that fall in this interval. 5 students over the total number of students, 27. Okay. So 5 over 27. We have to times by 100 because I asked for the percentage, and we get 18.5%. Okay. So let this not confuse you. Let us make this make sense for us. Okay, let's make sense of this rather. So there's a lot of percentages going on. So it doesn't mean that these students got 18.5%. What's saying is that the number of kids that got between 60 and 80 in that interval is 5. And then as a percentage of the class, it's 18.5. So about 20% of the class got between 60 and 80. Okay, a lot of percentages. Don't let that confuse you. Make it make sense for yourself. Okay, now, next question. Use the information on the frequency polygon to draw a cumulative frequency curve. Okay, important, very important word, cumulative. Okay, cumulative means adding. You're adding onto things, okay? So it accumulates, right? You can think about debt accumulation or homework accumulation. It keeps adding on to itself. Okay, so another important thing. In the ogive, we plot at the endpoints of the intervals. So we're going to be plotting at 20, 40, 60, 80, 100 at the endpoints. Okay, and also important, remember our ogive starts at the origin. Okay, anyways, so at 20, we're plotting at 20. And so we're going to plot at 20, but we know between 0 and 20, 1 student. Okay, so we're going to be plotting 1 at 20. Okay, so each block here represents 1, right? So 1, 2, where am I? 3, 4, 5. Okay, so each little block represents 1. So we're plotting there. Okay, now we know we're plotting at 40 because it's the end point of the next interval. Okay, so we look and we see, okay, between 20 and 20 and 40, okay, there were 7 students, but we need to add that 7 to this one. So we're plotting at 8 now. So we're plotting 8 at 40. So here's 5, 6, 7, 8. Okay, because we're adding. Okay, so before, between 20 and 40, there were 7. Okay, but now we're adding. Okay, so to interpret the ogive, let me plot one more point and then I'll talk about how we interpret the ogive. Okay, so now we look at 50 and we see 10. Okay, so now at 60, we're adding 10 to what was here. Okay, and remember this was 8. So we're adding 10 to that, so we go to 18. Here's 15, 16, 17, 18. So we plot here now. Okay, so let's make sense of this now. So if we look like this, okay, this is 18. So what this is saying is it's not saying that it's not saying that 18 students, okay, because remember you don't actually have to give labels, but this would be the number of students, okay, so number of students, and this is the results. Okay, the number of students or the cumulative frequency, okay, but it means the number of students. Okay, so what's saying here is it's not saying 60 students, it's not saying 80 students got 60%. What it's saying is 18 students got below 60%. 80 students got 60%, 18 students got 60% and below. Okay, whereas it was different with the with the frequency polygon, because firstly we plotted at the midpoints, okay, but what happened here is it's saying 10 students were between 40 and 60. Okay, so do you see the difference? Cumulative frequency means we're adding. Okay, we keep adding. Here, this is showing exact. It's saying, okay, between 40 and 60, 10 students. Okay, so this is a bit of theory. I hope that makes things a bit more clear if you're struggling to understand ogives. Okay, you don't need labels for this graph, by the way. Okay, and we don't need to show that as 18. Okay, where were we? We were plotting at 60, so now we're going to be plotting at 80. But remember, we look here at the midpoint. So we need to add another 5 to this. So this was at 18, we're adding another 5, so we end up at 23. So here's 20, 1, 2, 3. There's 23. Okay, and then for the last one, we're plotting at 100, and we're going to add a 4. So there was a 23, we add a 4, we're going to end up at 27. So here's 5, 6, 7. Okay, very important. How many learners did we have? 27. Where are we ending up? 27. Okay, make sure you're careful with that. Okay, and then to plot the ogive, I'm not very good at drawing, so let's see. It might take me 1 or 2 tries, but you start here, and it curves kind of like a snake or cobra. Okay, but you got to stop. You got to stop there. I'm gonna have to erase that little bit. You stop at that last point. Oh no, I went over again. Oh no. So it's not perfect, but I hope you guys understand. Okay, it's a bit tough drawing on this drawing pad. Okay, but it looks something like this. All right, so that's the frequency curve, cumulative frequency curve. Okay, now for D1, they say indicate on the horizontal axis of the cumulative frequency curve where you would read off the median. Okay, so we have to indicate on this graph where we would find the median. Okay, so the position of the median is, Q2 is the number in our sample plus 1 over 2. That's the position. Okay, that will be the position. So we have 27 learners. We add 1, it's 28. 28 over 2 is 14. So at 14 is where we would find the median. Okay, so 14 is here. So we track across 14 and we hit our curve and then we pop down. Okay, so it's about, what's that, 52% roughly. Okay, so here you put Q2, okay, for median, or you could write median over here. Okay, that is where we would find the median. Then they say the value is required to determine the IQR. Okay, so remember IQR is Q3 minus Q1. So we need to be showing where we find Q3 and where we find Q1. Okay, so this was again the position at 14. And then to find Q3, what we do is it's just 3 over 4 times by n plus 1. So I'll show you on the calculator how that looks. Here we go. So let me move this across. So what we do is we say, we know that it's 27 plus 1 over 2, which is 14. We can just say this thing times by 3 over 4. So at this position, 10 over 5. What am I doing? So what we do is it's over 4. Okay, and it's just 3 times by 28 over 4. So at 21. Okay, that is where we would find Q3. Okay, so yeah, it was initially what I wrote here. Yeah, I just did it wrong. So this thing tells you where Q3 is. Okay, or what you can do is you can just say this thing times by 1,5. I'll show you it's the same thing. So 21 and 1,5 times by 14. 21. Okay, so at 21, okay, that's not a very straight line, but over here is where we would read off Q3. And then for Q1, well, Q1 is just n plus 1 over 4. Okay, n plus 1 over 4. Okay, It's the first quartile. Okay. So if we do n plus 1 over 4, it should be 7. I'll show you. So n plus 1 is, we had 27 learners plus 1 over 4 gives us 7. Okay, so we read off at 7. There's 6, there's 7 over there, and that looks pretty much on 40%. Okay, that's Q1. Okay, so that should be our answers. Let me confirm with the memo. Let me show you what the memo has. We're going to look at it together. So memo has, so their graph is obviously going to be slightly different. Yeah, but more or less, let me shift this a bit. More or less, you can see that Q1 is pretty much by 40, like what we have here. Their midpoint, here's 50, is just to the right. Okay, so sorry, their midpoint, this is median. MD is for median, or Q2. And then the Q3 is just past 70. Okay, so yeah, you would get a mark based on your graph. Okay, so as long as you did this, indicate like we did, you would get your marks. Okay, so we would get that. So everything's fine over there. Cool. Then remember, you don't have to put anything here because we're indicating on the graph. Now they say using your answer to A and D1I. So here's D1I, median, and our answer for A was 53. They say describe the skewness of the data set. Okay, so remember the skewness of the data set has all got to do with the mean and the median. Okay, and what side the mean is of the median. Okay, so if the mean is on the left, then it will be left skewed or negatively skewed. Okay, so let's see what we have. Our mean is 53. Our median is, I get 52, okay, because there's 54, 6, 8. Okay, so I get 52. So you could say, which is a tough one. Okay, so let's look at this. So in my drawing, okay, because I'm doing it digitally and not too accurately, what I get is I get that the mean is to the left of the median. Okay, so what I would get is I would get a negative skew. I would say negatively skew, but I see the memo doesn't allow that, which is interesting. Okay, so they get that the mean is to the right of the median. Okay, so but what I think is, here we got the median to be 52. Okay, the median's 52, so I'll write Q2 is equal to 52. When we did our average, we got 53. These are so close to each other. Okay, oh wait. What was I writing over here? I was completely wrong. Sorry. What I have over here is that the mean is greater than the median. Okay, so if the mean is greater than the median, that means it's positively skewed. Positively skewed. Okay, what you could also say is that they're so close. You could say, well, the mean is equal to the median. Okay, so I see the memo uses words. I'll show you in a second. You could say the mean is equal to the median. Okay, so here's option 1. Here's option 2. They're so close. Okay, and also depending on your graph, you might find that they are equal. So the mean is equal to the median, which would mean that the data is symmetrical. Okay, so you have two options there. I will show you. The memo allows both. Memo does allow both. So this is what the memo allows. And again, I'm going to repeat what this is the memo's ogive. Okay, so my explanation's got a bit messy, but let me just summarize what I was trying to say. So the mean and the median are very close, okay? So if you look at the memo one, it's not that clear, but so here's 50. The median's just to the right of it. So this would be 55. That might be 51, okay? So you can still see with the memo though that the mean is greater than the median, okay? In that case, we have this option over here, positively skewed. But they are very close. So if you saw them being equal, sorry for the hadida, then this is another option. Okay, so this is option 1 and this is option 2. Both of them are correct. You wouldn't get a mark, I assume, if you drew this a bit poorly. What might have possibly happened is you might have had something like this, where your median you would actually see is actually greater than 53. So probably why this one isn't allowed, I'll put it in red, is this one probably isn't allowed. Okay, so what I drew here in blue, this probably isn't allowed because you would have drawn your ogive really wrong to come to this conclusion. That's why it's not allowed here. Okay, but I guess what you can do is, if you can't tell if they're very close together, the mean and the median, probably stick to this one. This one will be the safer one. Okay, because there might be a time where these are the two options that they will allow. Okay, but what's a common factor? It's always that this is close. Okay, so first step is draw your ogives properly, and then you won't run into this issue. But if you're unsure, choose this. Question 4. They give us this diagram. They say points A, B, and C all lie on the circle with center O. So here we got a center. They say line OA is parallel to CB. That's given over here. And OAC is 25 degrees. Okay, so they've indicated everything for us so far. No missing information we need to put in ourselves. And let's have a look. They say determine COA. COA. So it's this whole angle over here, O1 and O2. Okay, so let's look in triangle COA, this triangle over here. So if we look at that triangle, we'll see that this line is equal to that one because of radii. Okay, so then that means that C1 is 25. And then we can work out COA using interior angles of a triangle. Okay, so what we can say is that C1 is equal to 25 degrees. And the reason there's angles opposite, so angles opposite equal sides. Yeah. So it's angles opposite equal sides. Okay. Essentially, the reason there is we have an isosceles because these are equal. Okay. I see the memo allows you to also say radii. You can say radii. That will happen over there. But if you wanted to start off by saying that OA is equal to OC because of radii, yeah, feel free. Memo doesn't require it, but feel free. Okay. So now if we work in that triangle, we're just dealing with the last unknown angle. So we can say COA is equal to 130 degrees. Therefore, COA is 130. Okay, because it's the remaining angle. These two together give us 50. So then this one has to be 130 because of interior angles of a triangle. Interior angles of a triangle. Okay, not too bad, hopefully. Then they say determine O1. So just this little part over here. Okay, so let's now have a look at this triangle, COB. Okay, COB. Let's see what we can find out over here if we deal with this triangle over here. So again, we have an isosceles, okay, because these are radii. Okay, so if we could figure out this angle, that'll be helpful. But let's have a look. So we know what C2 is, and that's C2 is 25, right? Because of alternate angles. So this little bit is 25. Okay, that's 25 degrees. But we also know that C1 is 25. Okay, we showed that in the last question. Okay, so that means that this entire angle of B is 50. Okay, because this whole thing's 50, that's 50. So then this one is, if this is 50, that's 50, 100. This O1 is 80 degrees then. Okay, so let's start off by saying that C2 is 25 degrees. And the reason there is alt angles. So it's alternate angles, and OA is parallel to CB. Okay, so we can say then that therefore OCB, that angle is 50 degrees. And then we can say, well, therefore OBC, this angle over here, is 50 degrees because of angles opposite equal sides. I guess you could also say radii here again. Memo says, yeah, you can give either of those reasons. And then we can say, well, therefore, O1 is equal to 80 degrees because of interior angles in a triangle, or you could say of a triangle, interior angles of a triangle. Okay, so there we go. Not too bad, hopefully. And then question 4, the entirety was worth 5 marks. So not too bad. Okay, now we move over to a proof. Okay, required to prove. So these you can memorize. I don't like memorizing. I've spoke about this before if you looked at my other videos. I don't like memorizing things. I like to kind of work from principles. So essentially the principles here is you're dividing areas. Okay, areas of triangles. Okay, but the first thing is when we do these required to prove things, you do need to do a construction. Okay, so the construction is kind of something you're going to have to memorize. Okay, so for the construction, we need to make 2 triangles. Okay, and they've divided these 2 triangles here at the top, so we need to divide this one here at the bottom. Okay, so we're going to construct DC, and we're going to construct, I'll do it with a different color. We're going to construct BE. Okay, these 2 lines. So we have 2 triangles now, right? So here's one triangle, so BDE. And then we have another triangle over here, DEC. Okay, and we're going to need that, right? Because here at the bottom, you can see it references DB. So obviously, when we deal with this one, we're going to have to be dealing with this triangle because it's got DB in it. And then over here, when they talk about EC, we're going to have to be dealing with this triangle because it has EC in it over there. Okay, so you get a mark for your construction. And now remember we don't have to memorize all the individual steps. We just memorize we're dividing areas. Okay, so we're going to area of triangle. So area of triangle, and then they mention AD over here. So we're going to be dealing with ADE, this thing over here. So the area of ADE, the area of triangle ADE over, and then here they mention DB. So it's going to be this triangle over here. So it's area of triangle DBE. Sorry, BDE. BD. I said D, wrote a E, BDE. Okay. So remember, area of triangles is just half base times height. Okay, so and remember this height is a perpendicular height. All right, so let me use a different color. So it's a half times by, what's our base of triangle ADE? Excuse me, ADE. So here's our base and here's our perpendicular height of this triangle up here. I'll show it in red. We're dealing with this triangle up here. Okay, here's our base and here's our perpendicular height. Okay, that's why this was constructed for us. Okay, and that's the exact reason why. No, don't worry about that. Don't worry about that for now. Okay, so that's our perpendicular height. Okay, so our base, as I was saying, was AD. Okay, and we know we're using AD because it's up there. Okay, it's this first one over here. Okay, so that's our base, and our height is this perpendicular height over here, which is FE. Okay. So what needs to happen now is things are going to have to cancel in this first area. So we're going to get AD over DB. Okay, so let's have a look. So we're now dealing with triangle BDE, which is this thing over here. Okay, so because I mentioned DB, all right, we're going to use this as our base, the base of the triangle. Okay, we could write it as BD. I'm going to write it as DB because that's how it is in the question, but it's the same thing. And now we need to ask ourselves, for this triangle, what is the perpendicular height? Okay, and the thing is, the perpendicular height of this triangle is actually the same as, it's not even this, it is the same, but it's just this line over here. EF is the perpendicular height from this base. If you extend this base, the perpendicular height is this length over here, FE. So this is what we were expecting, right? Excuse me. Because we need things to cancel. right? So obviously the halves cancel and these FEs cancel. So then we have AD over BD. Sorry, DB. Yeah, DB. I said DB. Okay, so that's our first area. I'm going to run out of space here, but I will make a plan. So this is our first step. Okay, so now we got this ratio, right? Because this leaves us with AD over DB. Okay, so this thing's sorted. Now we just need to do this little bit over here. Okay, so let me erase this. Okay, I erased our construction. I'll put it back. Our other construction was here. Okay, we're going to be doing this using this triangle now. This one over here, and the reason is because EC is mentioned over here. Okay, and also AE is mentioned at the top. So now what we're going to be doing is still the area of ADE, but now we're going to be using this as our height and this as our base. Okay, stick with me, you will see in a second. Okay, so the area of the top triangle has to stay, so you have to still mention the top triangle. Okay, it's the same top triangle over here and here, same top triangle, ADE, but now we're just using a different base. You'll see in a second. Okay, and the area at the bottom is a different triangle. It is now DEC. DEC. All right, so our area of the top triangle is a half, and now we're looking from this context. So now this is our base, AE. Okay, and you'll see why we're going to need this in a second. And this is our perpendicular height, DG, or yeah, I'm going to call it GD. Okay, GD. And you're going to see why we need to use, so the reason we have to use AE is because it's given over there. Okay, and if this is our base, that's our perpendicular height. Okay, and then here at the bottom we have a half, and our base here is EC. We know we have to use EC because it's there at the bottom. Same story. And now again, if this is our base, EC, the perpendicular height from our base to this point over here is GD. Okay, but we knew it was going to have to be GD because these were going to have to cancel. Okay, so now what we have, these cancel, they're the same, and the GDs cancel. So now we have, I'm going to write it here, AE over EC. Okay, so now this part is sorted. Okay, now the next thing we have to do is show that they're equal. Okay, so this is a little bit of theory that you need to memorize. So I'm just going to continue up here with this problem. Let me choose a color. Let's do red. Okay. So now we need these things to be equal. Okay, so let's see how we can do that. Okay, so the thing is, we know that this area is equal to this area because they're the exact same triangles. Okay, the areas are equal. What the connection needs to be is this thing now needs to be equal to this thing. Okay, so we're gonna say, but, okay, you don't really need the but here, but we're gonna say, but the area of triangle BDE is equal to the area of triangle DEC. Okay, we need to have a reason here, and the reason is same base between parallel lines. Okay, so the reason is, some people say same base, same height. I'm sure that will be fine. So, but essentially it's same base between parallel lines. Okay, so let me explain that. Okay, so what happens is, if you have two parallel lines like we have here, okay, it was given that this was parallel, and you draw two triangles like this. Okay, the thing is, these two triangles, they have the same base. Okay, and that same base is this BC. Okay, because if we look at this triangle, sorry, BC is not, I was very wrong, that BC is not the same base. DE is the same base. Okay, because what I'm going to do is I'm going to start off by tracing one triangle. Okay, so here we have one of the triangles. Okay, so what you'll notice is I cross DE over here. This is my base, okay, of this triangle we called it BDE. Okay, I just drew BDE. Now I'm going to draw DEC, triangle DEC, and you'll see again, if I trace, DE is my common base. Okay, so if we have the same base and we have two triangles between parallel lines, then the areas will be equal. Okay, Now that we have that, we can then say, therefore, AD over DB is equal to AE over EC. Okay, because remember, this is what we were required to prove, so don't miss the step, important step over here. Okay, I hope that was clear for everyone. Cool, it was just a proof. Now we move over to B. They give us this little diagram over here. They say HIJ is a right angle triangle at I. So we have this. This is probably going to be quite important because they tell us about it. They say L lies on IJ such that JL is 9, LI is 12. They give all of that. Don't stress too much. K lies on HI. Here's HI, there's K, with these two lines parallel. That's probably important. You can see we're going to be doing line parallel one side triangle. And HJ is 29 units. Okay, so we have all of that information. And now the only question for this part B is determine the length of IK for 5 marks. Okay, so we're probably going to have to be doing some steps in between. So they haven't scaffolded the problem when they say work out this first, then hence or otherwise work out IK. They just chuck you in the deep end. So we need to mentally think about these steps. So let's do that. We need to work out IK, this length of IK over here. Okay, so what you'll notice is here we have a right angle triangle. So if we know the length of LK, right, we can use Pythag to work out IK. Okay, so let's try work out KL. Okay, and so again, so the memo does it in a slightly different way. I might paste that, how the memo did it, but I'm going to work with my way. Okay, so I'm going to work with my way. So this thing I'm about to show you it doesn't often come up. Okay, so let me explain. So a lot of the time you would be dealing with something like this. Okay, so because we have this this parallel line over here, we know that IL, so we have that IL over IJ is going to be equal to IK over IH. Okay, because of line parallel one side triangle. So this comes up often, right? I mean, you can even do this, right? Where you're going to be saying IK over KH is equal to IL over LJ. Okay, so there's a few different ratios we can do, but the main thing is they're always with the sides of the triangle, never these bases. Okay, but it is very true that if we do this side over this base, okay, is going to be equal to this side over this base. Does that make sense? Okay, because here, if we look at this mini triangle, what I'm doing in the mini triangle, I go the entire length of this bottom side and then the entire length of this right hand side over here. So if we look in the big triangle, if we just ignore this little triangle, you see how I have to go across the entire length and then across this entire right side. Okay, so I hope that isn't too confusing. It doesn't come up often, but it is something I've seen before and it is helpful. Okay, so essentially what I'm going to be doing is I'm going to be saying that IL over LK is equal to IJ over JH. Okay, and the reason there is line parallel one side triangle. Line parallel one side triangle. Okay, so IL I know is 12. LK is what I'm trying to find because I'm trying to do Pythag over here to find IK. And I know that IJ for this whole thing is 21, 12 plus 9. And then JH was just given as 29. Okay, so what I can do is I can solve for LK. So you can just cross multiply here. So LK will be 12 times 29 divided by 21. Okay, I'm going to leave this, I'm not going to round. It's 116 over 7. Okay, that is LK. So what I'm going to be doing now is I'm going to do Pythag. I'm going to say that IK squared is equal to LK squared. So 116 over 7 squared minus 12 squared. Okay, and that's because of Pythag. Okay. All right, we're just working now Pythag in this triangle over here. Okay, so if I do this in my calculator, I'll find that IK, so I do 116 over 7. I take the square of that minus 12 square root that, and I get 80 over 7. Okay, which is 11,4 units. Okay, that is what I get for IK. So I'll show you in a second what the memo does. So what I want to do is when I tutor some students, okay, we got the calculator. So what I was saying is when I tutor some students, I see some of them struggle, not so much struggle to use the calculator, but they use the calculator in ways that I think are quite inefficient. They just show that they're not so comfortable with the calculator. Okay, so what I'm going to be doing is I'm going to be doing this in my calculator. Okay, so what I can do is just 116 divided by 7 squared. Okay, minus 12 squared. Okay, so, and I get this answer. This answer, I don't know why the calculator is being weird here. So this answer, wait, what do I get? 116 divided by 7, this thing squared minus 12 squared. Oh, no, this is the right fraction. Sorry, I don't know what I was talking about. So essentially, what a lot of students what they'll do now is they're going to say 6,400 over 49. So wait, they're going to take the square root of this, 6,400 over 49. So a lot of students, I don't know why, but this might be super obvious for you, but some students struggle. So ans, if I press A and S, this is my previous answer, what I just calculated. So what you can do is just square root of ans, which is 80 over 7. Which if I change to a decimal is 11,4. So there you go. This calculator is slightly different. I don't know why this is in brackets, but don't worry about that. That's 11,4. Okay. And another thing is I don't have to be saying 116 over 7 and then squaring that, right? I can just do 116 divided by 7. Saves me a bit of time. For me, it's easier than dealing with the fraction. I get this, and then I minus by 12 square. How easy is that? And then I just square root answer. Okay, so if this was obvious for you and you're just saying, okay, well, that's obvious, that's good. Glad you're comfortable with the calculator. Some people might look at this and be like, whoa, I didn't realize this. Okay, so my point is make the calculator your friend. Okay, you don't want to be wrestling with your calculator in the exam. Okay, so what I'm going to be trying to do more in my videos is show the calculator more. So you can kind of see what I'm doing in the calculator, and maybe there'll be ways that you can save time or ways that you can become more comfortable with the calculator. That's my hope by showing the calculator. Okay, so I know I spent a bit of extra time on that, but I just wanted to make that point. Okay, so what I'm going to be doing here is showing what the memo did. I'm going to be doing this. I'll show us over here. This is what the memo did. Okay, so let me quickly erase all this stuff in the background so it doesn't bother us. Okay, let me get rid of this. Okay, so what the memo did here is they work out HI. So they work out this entire length, okay, which is quite easy because they're just dealing in the big triangle. They're doing Pythag over there, okay, and they get HI is 20 units. So this whole thing over here is 20, okay. Then what they do is then they just do a ratio, right? They do, I can't remember if we used this exact one. No, this was the first one I wrote and said you could use this one. This is the normal one. So then what you can do is you can say, well, this, let me use a different color for this side. You can say, well, this over that is going to be equal to this over the whole thing. Okay, so you can see IL over IJ is equal to IK over the whole thing over here. Okay, when they do this, and then they get the same IK. So I just did it in a bit of a different way because I didn't want to work out this whole thing first. I wanted to directly work out this, then do Pythag. It was just the way I wanted to do it with this information. I saw that it was really easy to get this, and then I can do Pythag. That's just the way I saw it. But I know a lot of students aren't comfortable with this step over here when you have to, when it's not just on the sides, when it's not side ratios like this, when it's actually you have to move to the bottom, the side and then the bottom. So if you didn't really understand how I was doing that thing, you can just follow what the memo did here. But if I taught you something new, it is sometimes helpful to know you can do line parallel, one side triangle ratios like that. It is helpful information to know. So I hope that if I taught you something new in the previous step, but if you didn't understand that new way, then feel free to look at this method from the memo. For question 6, we need to plot these two functions over here, f of x and g of x, on the interval -90 to 180 degrees. So we have to label the intercepts with axes, the turning points and endpoints. Okay, don't forget these. You will lose marks if you don't include these. A lot of students forget to plot the endpoints. Okay, super easy. We're going back to the calculator. Back to the calculator. So there's a thing called table mode. Use it. You literally have to do no thinking if you just do table mode. Okay, if you didn't want to do the table mode, what you could do is, well, you would realize that this thing over here is just the period is now 180 degrees instead of 360. This one is just a normal cos graph shifted 45 to the left. So you could do that and interpret it that way, but the easiest way is literally just use the calculator. So now we have cos of x plus 45 degrees. We press equal start. We want to start at -90. We want to end at 180 degrees. And stepping, you can see here that the steps on 45. So let's step in 45s. So let's start off by plotting sine of 2x. So you'll see here we go 0, -1, 0. So let's plot these. So -90 is 0, -45 was -1, then 0 was 0. Let me just confirm that. Yep. And then 45 is 1, 90 is 0, 135 -1. So 45 is 1, 90 is 0, 135 is -1. So then this one should be here, right? If we're following the shape. Yeah, perfect. Okay. So let's fill in this. Well, let's draw this rather. So it's going to look something like this. Remember, my drawing is not the best. But this is just the normal sine graph with a period of 180. So that just means we complete one full wave in 180 degrees rather than the usual 360 for sine. Okay, so that's our sine one. We'll label everything in a second. Let's just rather draw the cos graph first. Okay, so for the cos graph here at -90, we're at about 0,7. So 0,7 will be somewhere up here. Then at, wait, where did the calculator go? My calculator just crashed. Okay, I closed the calculator by mistake there. But -45, we're at 1. Then at 0, we go back to 7, 1. And then 45 is 0. So this should be the same height as that one. And then at 45, we're at 0. Then at 90, where are we? 90, we're at -7, 0,7. Then 135 is -1. And 180 is negative. So it's going to look something like this. 0,7 is about here. And then we end off at about 0,7. Let me put it a bit higher. I put it about here. Okay, so these ones are maybe a bit too high for 0,7, because here's 0,5, 0,75 will be about there. So 0,7 will be about here. Okay, so let's complete this graph over here. And again, my drawing is not the best. Okay. Oh, that wasn't too bad. Okay, all right, that's kind of smooth. Okay, so there's our graph sorted. Let me change view here. Okay, there's our graph sorted, but we are not done, we need to do some important things. We need to label intercepts with the axes. Okay, so let's first start off with f of x. Let's also label this f of x. Okay, and yeah, you don't even need that f. You could add that of x. You could just label this f and this one g. You don't really have to do this, but it might be helpful for some of the questions later. Okay, so anyways, let's label this. This is negative 90 degrees 0. This one is negative 45 degrees 0. So this is the endpoint, this is turning point while we're labeling. This is the intercept, so we're labeling this. This is a turning point. Okay, so you get the idea why we're labeling these points. Here's another intercept. Here's a turning point, 135 minus 1. Okay, so I messed up a bit. This one should be 1. This one should be negative 1. So be careful with that, don't make mistakes like I did. These things do happen though. Okay, so that should be fine for the sine graph. Let me double check. Why have they not labeled this on the memo? Nevertheless, I'm pretty sure I got everything. Intercept, 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 turning point, turning point, turning point. So these are negative ones, that's 1. Okay, that looks fine. Then for this one, we know it's negative 90 degrees, and then that 0.7, okay, to 1 decimal place, 0.7. Because if I show you in the calculator again, got to change the view, there's a calculator, you can see that it was to 1 decimal place will be 0.7. Okay, because remember the front of the paper asked for 1 decimal place. Okay. So 0.7, here's a turning point at negative 45 degrees 1. Okay, here's intercept with the axes. Okay, careful, don't forget the intercept with the y-axis. This is 0 degrees 0.7. Okay, getting a bit messy, but it's okay. 45 degrees 0. Then we don't have to label this, it's not intercepting any axis. Here's a turning point, so we are going to label this. Things that's already labeled, to be honest. I wouldn't label it twice. Let's not do that. Here is an endpoint, so we do need to label this. And this is negative 0.7. Okay, anything I'm forgetting for the blue graph? No. Okay, so this is 6 marks. Easy 6 marks. You can literally use the table. You literally connect the dots and then just label the points. Don't forget the endpoints. Okay. So relatively easy 6 marks. And now for B, for 5 marks, they say determine the values of x. Excuse me. X is an element of negative 90 to 180. So x needs to be between that, for which f of x is equal to g of x. Show all calculations. Okay. So we can't just read off the graph. So they're asking for the points of intersection. So here's one and there's another one. Okay, so we know what the solution should be. This one will be about half of 45 is 22.5. So we know one of the answers are going to be about 22 degrees and the other one is going to be 135 degrees exactly. But we need to show the calculations. Okay, so f of x is sine of 2x and g of x is cos of x plus 45 degrees. Okay, so the issues is you could convert this into 2 sine x cos x, but the problem is what you're doing here is you're introducing this random sine x. Okay, so let's change both of them so they're both ratios of cos. Okay, so this should be cos 90 degrees minus 2x. So yeah, we changed it to this because of reductions. Okay, so whenever you have sine theta, you can just write that will be the same as cos 90 degrees minus theta. Okay, in this case our theta was 2x, so then this is now 2x. Okay, so that's why we have this over here, and then we have cos of x plus 45 degrees. Okay, so now we have the same ratio. They're both cos, a single ratio. So what we can do now is we can say, well, 90 degrees minus 2x is equal to x plus 45 degrees plus, and then k360, because we're dealing with cos. Okay, and then remember Kes. If you're from Kes, this is easy for you, should be easy for you to remember. Okay, K is the element of integers, Kes over there. Okay, so now we need all the x's on one side. So normally on the left, so we have negative 3x is equal to negative 45 degrees plus K360. Okay, but they're asking for the values of x. So we just need x by itself. So we divide everything by negative 3. So this should be 15 degrees plus K120. Do not forget to divide 360 by 3 as well. Okay, so this is the general solution for x. They want the solutions that fall between negative 90 and 180. Okay, so you'll see if we go in the calculator, I said I'll be showing the calculator more. Let me show the calculator. So we get out of table mode. We can do 15 minus 120. Let's see where we end up. Negative 105. So that's to the left of this range over here, which is not good for us. Okay, it's out of the range. Okay, so one of them is 15. Okay, that's kind of easy. So we can say x is equal to, one of them will be 15 degrees. I said it would be about 22,5. So that's close enough, right? Remember, because that was just the estimate from our graph over here. Okay, but we knew it was going to be around 20-ish. Okay, so now let's do 15 plus 2 times 120. Okay, so now we're making our K2, and we get 255. Oh wait, I haven't done this one first. Okay, so that previous one was out of the range. This one's in our range. Okay, 135. We knew we had to get this 135 because it was from the graph. Okay, so there you go. Those are our values of x. So x is equal to 15 degrees or x is equal to 135 degrees. Sorry, I'm yawning so much. Whew, hopefully you're not yawning as well. Hopefully I'm not that boring. Okay, I guess I'm boring myself over here. Okay, now they say use your graph. So we have to use a graph to determine the values of x as an element. So between this range for which this is true. Okay, so you can use a graph, but you can also definitely use these answers before. Okay, so we need the sine graph above the cos graph. Okay, that's literally what this means. Okay, because this is greater than. Let me just make sure I'm not in the calculator view anymore. I was. Okay, so things, sorry, you wouldn't have seen where I was pointing. Okay, so this, what was I saying? Okay, so the F graph needs to be above the G graph. That's literally just what that means. Okay, so remember our F graph is red. Okay, so again, what this means is this is greater than or equal to. Okay, so we need the F graph above the G graph. So the red graph above. Okay, so I'm gonna whip out the ruler, and what we do is we put it vertical. So this is a technique that can sometimes help, and you can see here, while blue's above red, blue above red, blue above red, here they're equal. Okay, we ask ourselves, are we allowed to be equal? And you can see we are, because it's greater than or equal to. Okay, so we know that from this point we're equal to, and now red is above, red's above, red's above, red's above, red's above, red's above. Here they're equal. Okay, here they're equal, but then red stays above. Okay, red stays above. Okay, so essentially from 15 all the way to 180, red is above. Okay, here it's equal, but we're allowed to be equal. Okay, so what I recommend is use interval notation. So we're going to say x is an element of, and 15 degrees. Okay, this was the point of intersection 15 degrees. We got the 15 from here. And we need to say, are we allowed? So my question is, are we using a round bracket or square bracket? And the thing is, it's a square bracket because we're allowed to be equal to. Okay, we're allowed to be equal to. So the graphs are equal to at 15. So we can include that. Okay, all the way up until 180 degrees, also included. Okay, also included. So that would be our answer over there. Okay, you can also put it in, so this interval notation, you could put it in set builder, where you would say, well, x is between this. Okay, x is between this. Okay, yes. All right, now for this one, it's saying f times g is less than 0. Okay, so remember, these are just y values. Okay, so it's saying the y of f times by the y of g is less than 0. So let's think of any two numbers. If you have a times b, and it has to be less than 0. Okay, less than 0 is negative. Okay, how do you get a negative number? Well, one has to be negative, one has to be positive. Okay, if you times two numbers, because if they're both positive, you'll end up positive, and if they're both negative, then negative times negative gives us positive. Okay, so we either need this to be negative and that to be positive, or this to be positive and that to be negative. So essentially we need one above the x-axis and one below the x-axis. Okay, so we're going to whip out the ruler again. Okay, you'll see at this point, all right, so we need to ask ourselves here as well. We need to be careful. Okay, so f at this point is 0. Okay, so if you take a number and times it by 0, you're going to get 0, but we're not allowed to be 0. Okay, so we can't include this point over here. Okay, we can't include it. Okay, so when we do our bracket, we're not going to have a round one there. Okay, but what's important is you can see blue's above the x-axis. So what we're doing is we're looking here at the x-axis. Okay, here's the x-axis here in green. Okay, so remember the y value here is positive 0.7, and here it's 0. Okay, so that's why we can't include this. But then over here, for example, it's a positive value and here's a negative value. So if you times these y values, then you get a negative. So that's why it's allowed. Okay, because remember it's just looking for above the x-axis and below the x-axis, which is true here. Okay, well, not here. Here this one is on the x-axis, the red one. Okay, but from here we have above the x-axis and below, above and below. Here f is now 0. Okay, and then from this point they're both above, so we don't need this. We don't need any of the shenanigans, right? So let's start writing this interval. Okay, let us answer the first bit of the question. Okay, so x is an element of, okay, we can't include negative 90 because it's 0 here. Okay, so what happens is if you times those numbers, we will get 0, which we're not allowed to be. We have to be less than 0. Okay, so we cannot include negative 90. We cannot include it. Okay, then we go up until, if we look at the ruler, we went up until 0. Okay, but again, we cannot include that 0 because if you times them, you would get 0 there. Okay, so 0 degrees is excluded. Okay, now let's see, is there any other region where this is true? So from here, they're both above, both above, both above. From here, blue starts to go below and red's above. So red above, blue below, above, below. And then here, they both start going below. Okay, they'll both start going below. So it is from this point. Okay, but again, we cannot include that 45 because it is 0 over there. Okay, so it's going to be 45 up until 90, and we cannot include the 90 because it's also equal to 0. Okay, so when we answer, we're going to say union. So basically we cannot include the 45 degrees and we cannot include the 90 degrees. So that's why they are round brackets. Okay, so that would be our answer over there. Okay, hopefully that made sense. Okay, this is the first half of the paper done, section A. So essentially half of the paper, 73 marks out of 150. And now we move over to section B as I continue to yawn. Let me have a quick yawn break. Okay, we are back. So firstly, I said I was going to have a quick yawn break. That turned into a coffee break, and then I had to deal with a million different things, which is partly why the videos take so long to get out. And then I started filming again, well, not filming, recording again Sunday morning, and it was a nice rainy morning. I wish you guys all the best on, I know a lot of you guys watch these videos, well, I assume you guys watch these videos on the weekend. Wish you all the best and a nice cozy study session. And then when I was editing, I basically finished the paper, and then when I was editing, I realized I didn't have any audio. So this is take 2 from here on. I didn't have proper audio. So yes, we are back. The good thing is I made a lot of mistakes. It was a bit messy. I needed more coffee, obviously, I was making a lot of mistakes, so hopefully I don't make so many mistakes now. But one thing I mentioned in the previous recording that I want to mention now that we actually have audio is this. I got a comment from someone over the weekend. They said that they were watching the videos as a CAP student and that the IB is not as difficult as many people think it is, or make it out to seem, or make it seem rather. And I completely agree. I don't agree with syllabus bashing. I think it's a bit stupid. But one thing with the IEB is they call it dynamic geometry, where you actually have to do your own constructions, and it requires a lot of creativity and quite an in-depth understanding of the maths, right? So let's talk about it when you have to do constructions. So you're going to see when we tackle this problem or why we need to do constructions. But the main goal is you're going to want to solve something. Okay, you're going to want to solve something, but you're going to hit a roadblock. And you're going to have to, there's going to be the step where you have to solve this roadblock. You need to get around this roadblock to then solve the final problem. Okay, so there's going to be a roadblock. And often what you're going to have to do is make a construction to get through that roadblock. Okay, you're going to have to solve something in the middle to then solve the final thing. Okay, and it's often a construction. So normally the question comes in section B. So we're in section B now. So these type of construction questions normally come in section B of maths paper 2. Okay, so when we do the problem, you're going to see where the construction comes out. And I'm going to walk you through the thinking behind it. So take note of how we're thinking through the problem and how I talk through the problem. Okay, so just keep that at the back of your mind as we go into this problem. Okay, so we have ABD is a semicircle with center O. Okay, so we have a semicircle, and so we have radii. So this is equal to this because they're both radii. Okay, they say CB is a tangent to the semicircle at B. So we know that this is 90 degrees. Okay, because tangent is perpendicular to the radius. So they give us OB 7 degrees and CAB is 38 degrees. Sorry, OB is 7 units. Okay, so what you can see is we kind of have some Pythag options here. We know that the whole of AB is 14 units because this is 7 and that's 7, so the whole thing is 14. So maybe they're going to ask us for this hypotenuse AC, so we might have to figure out CB. Let's see what they ask. Okay, they say determine the length of CD correct to 1 decimal place. State all relevant reasons with your statements. Okay, so they want CD, this little bit over here. So now we need to come up with some ideas. We need to think of some approaches to get CD. Okay, so one option is we can make a construction like this. Okay, it's a possible way, right? But the problem is, how are we going to determine this length or this length to then do Pythag for this, right? So we need to be thinking that if we get CB, then we can get AC. Okay, or let's not even think about CB. If we can work out the length of AC, okay, and we have AD, then we can work out this little bit, okay? Because we know if we add AD, so let's say AD is 8, and the whole length AC is 10, then we'll know this will be 2 units. Okay, so that's a possible approach as well. Okay, so we're going to try find the entirety of AC. Okay, and then we're going to try find AD. Okay, so sometimes you have to try different approaches, but it's really important that here it's a bit unclear. They just say find CD, determine the length of CD. So you need to think of approaches, okay, to do this. Okay, so the one where we find AC first and then AD, let's try that approach. So sometimes when you'll do this, like the first one, the first approach that we spoke about, you'll see that this one is a bit tough to do. Okay, so think through or even try some of these approaches. And if you don't get it at the first time, that's okay. That's just one way that you found out didn't work. Maybe you find some useful information of why it didn't work, or maybe it gets you thinking in the right way. Okay, so don't get demotivated if you try one approach and it doesn't work. Okay, it's actually a good thing sometimes where it can guide you. All right, so anyways, So we know that this is equal to this because of radii. So I know AB is 14 units. Okay. Good. I also know that this is 90 because we have, here's a tangent, it's perpendicular to the radius. Okay. So what I can do is I can find AC now, right? I can find AC because I can do just a normal tan. Not tan. Sorry, I can do trig ratio. Okay, because here I have my adjacent and here's my hypotenuse. So I'm going to do cos. Okay, you'll see that in a second. But first we have to say some reasons over here. So we're going to say that OB is perpendicular to CB. And the reason there is tangent is perpendicular to radius. Okay, so we need to say that for this being 90. Then we're going to say that AB is equal to 14 units. And the reason there is radii. Okay, because AO is equal to OB. So then if you add them, obviously you'll just get double of the radius because AB is the diameter. Okay, so now we can find AC. So what we're going to do is we're going to use cos of 38 degrees. That's our adjacent, which is 14, over our hypotenuse, which is AC. Okay, so we're going to get AC is equal to, let me open up calculator here for us. Let me put it here. Okay, so what we're going to do is AC comes this side, so it's 14 over cos 38 degrees. Okay, so AC, we're going to put this to 4 decimal places, so 7663. 177663 units. Okay, so it is good to work to, I like to work to 4 decimal places in while I'm working, and then obviously final answer 1 decimal place. Okay, yes, so AC is, the whole thing is 17,7663. Let me just confirm that. Yes. Okay, so now we have AC. We have this whole thing. So now we need to find AD, this thing over here, AD. So let's think, it's a bit tough. We're not exactly sure how to get AD at this point, right? So we need a construction, okay? Often a construction is a radius. We need to construct another radius, okay? So let me first explain what the memo did, okay? So you can follow along with the memo, but what the memo did is they constructed DB, okay? This is 90 degrees because of angles in a semicircle. And then what they did is, I believe they did Pythag from this point. They did something with Pythag. They worked out the length of DB and then also CB, and then they worked out CD directly. Okay, so that's fine. Okay, but for me, that's not the most obvious construction. For me, the most obvious construction is this radius over here, constructing OD. So we know that this is 7 units. So this is 7, this is 7. But we also know that this is equal to this because of radii. So that means that this angle is equal over there. Okay. And then I can work out this angle. You'll see how we do it in a second, but just thinking through it, I can work out this angle because it's just the final angle in the triangle. And then I can use the sine rule to get AD. All right. And once I have AD and I have AC, I can subtract them to get CD over here. Okay. So let's get into that. So what I'm going to say is, it's good to say what construction you're doing. Okay, so obviously show it on your diagram as well. They will be able to see it, but also write it. So we're constructing OD. Okay, OD. Radius OD. Okay, so if we construct OD, this is 7, right? So what we're going to have is we're going to say that angle ADO is equal to 38 degrees. And the reason there is angles opposite equal sides. Okay, because we have an isosceles triangle over there. So what we can say now then is, well, therefore AOD is equal to, and well, that's just, it's going to be 180 degrees, 180 degrees minus 2 times 38 degrees, which is 104. Okay, so AOD is 104 degrees because of angles in a triangle. Excuse me. So this is 104. So what we can do now is the sine rule. So what we're going to say is AD over sine 104 is equal to, and we can use whatever. Let's use 7. Well, it's going to be 7 over sine 38, no matter which one we use. Okay. So when we do that, we're going to be getting that AD is equal to, so in the calculator, what we'll do is we're just going to do 7 over sine 38 times by sine 104. Okay, when we do that, we get this 0322, 11,0322 units. Okay, so we have that. So we can say, well, therefore CD is equal to, well, yeah, so maybe not so much therefore. So let's say we can say that CD, this thing over here, is equal to AC, the total, this total length, minus AD over here, AD. Okay, so therefore CD is equal to, so we're just going to put this and this in our calculator. Okay, so when we do that in the calculator, I can keep this in the calculator, and I'll do 17,7663 minus that answer. Okay, so CD is 6,7. Okay, remember that I wanted 1 decimal places. 1 decimal place rather, 6,7 units. Okay, that is the length of CD. Let me just confirm with the memo. Yes, 6,7. Okay. One thing I want to show you is, if you don't want to round over here, it's a bit tough keeping this answer. We worked it out over here, right at the top. Okay, we worked it out over here. So if you're not comfortable working with 4 decimal places, you think you're going to get it wrong and you want to keep all the decimal places, I want to show you one thing you can do. So remember, the way we got this is by doing 14 over cos 38, 14 divided by cos 38. That's how we got that. So what you can do is you can press shift store. You see how that says stow over there, or store, and we can store it into B, for example. I should have stored it A, but it's fine. Stored it in B. So if I do alpha B now, you'll see that this is my value over here. Okay, so what I can do is when I work this out, so this I'll store actually as C. Okay, so I'll do 7 over sine 38 times by sine 104. Oops, 104. And I get this. So what I can do is I can just stow this in C. All right, so when I then do this, I remember that the first one was stowed at B. All right, it was that 17,763, and then this one down here was stowed as C. Okay, that was this one over here. So what I can do is I can just do B minus C, and you'll see even in, so this is using no rounding, I still get 6,7. Okay, so hopefully I taught you something new there. It is super helpful. It can be super helpful in, especially in grade 11 finance, when you have all those different timeline stuff. So yes, you can, this can be helpful. Okay, but if you work to 4 decimal places, you can see that we still get the same answer. Okay, this sometimes takes a bit of extra time, but I wanted to just show you because it could be useful, could be helpful. Okay, but normally working to 4 decimal places in the middle of your answers is more than fine. Okay, cool. So that is how we get CD. All right, so what I hope you noticed there is we ran into a roadblock of, we worked out AC perfectly fine, but then the next roadblock was AD. How do we find AD? That was the roadblock. And there's multiple ways to do it. For example, as I said, the memo did this construction over here. So then this is 90 and this is 90. And then what they did is they found this angle by being in the big triangle, and they worked out this length. Oh no, they didn't even work out AD. So what they did is they just worked in this big triangle over here. They found CB by using in this triangle, so they found CB by doing trig in the big triangle, and yeah, once they had this, then they just found that directly, also by a trig ratio. You can have a look at how the memo did that. Okay, but the main issue is we had this roadblock in the beginning. Sorry, not in the beginning. We had the roadblock where our roadblock was finding AD. Okay. Yes. So you kind of need to think about how you can get to CD. And yeah, you'll see that if you don't do a construction, there's a big roadblock. So you need to make a construction, either this one or this one, to then get through the problem, to get through that roadblock. Okay. So yes, I hope that discussion was helpful. Okay. So now we're given this question here. So given cos theta is a squared minus b squared over a squared plus b squared, and then they give us this thing. So here it's just saying that b and a are bigger than 0 and a is bigger than b. Okay, and here sine theta is negative. Okay, so this, I know this thing looks super confusing, right? But normally when they give us a cos theta, normally they give us something like cos theta is 5 over 2, and then they say sine theta is negative, right? So that just means we're going to be doing trig in the Cartesian plane, right? So we know that, so how I remember it is sine cos theta. This is how I was taught at school and stuck with me. So sine theta, shelter your rear, cos x raise tan your exterior. Okay, so cos, we know that this will be our x and this will be our radius. Okay, and sine is negative, so then we have to be in this quadrant over here. Okay, so we know this will be 5 and this will be 2. Okay, so this isn't possible what I gave here, because your radius has to be bigger. But yeah, I hope you get the point over there. Okay, so that, I know this question looked confusing, okay, with all this a, b, squares and stuff like that, but think about where you've dealt with this type of thing before. Okay, they give you some ratio and then they say determine another ratio. So obviously you're going to need your x, y's and r's. Okay, but let's think about what quadrant we are in. Okay, so sine theta is negative. Okay, so if I do the quadrants again and I do the cos diagram, all students take calculus. Okay, so sine theta is negative, so we can't be here or here. Okay, because sine is positive there. So we were between these two quadrants. So let's find out which one we're at. Okay, and to find which one, we have to look at this piece of information. So a is bigger than b. So if you take a squared minus b squared, a squared will always be bigger than b squared. So this thing here at the top is a positive. Okay, this thing here at the bottom is always positive. So if you take two square numbers and add them, it'll always be positive. Okay, so we have that. So we know cos theta is positive. So the only quadrant we can be in then is this quadrant over here, 4. Okay, so let's draw where we're at. We're over here. So remember what I was saying earlier, cos x raise. Okay, so cos is x over r. So this thing here at the top is my x, and this thing down here is my r. Okay, so here's my x. It is a squared minus b squared, and here's my r, a squared plus b squared. Okay, so to determine tan theta, what I'm going to need is, remember, tan theta is tan your exterior. I need my y. I have my x. I need my y. And to find my y, what I can do is, this is 90 degrees, so I can do Pythag. Okay, I can do Pythag. So what I can do is I can say y squared is equal to r squared minus x squared. Okay, so my r squared is going to be a squared plus b squared, because that's my r, all squared, minus my x squared, which is, this is my x squared. Okay, because of Pythag. Alrighty. So what I'll do here is I'm going to show you the short way. So it's a4. So you can write this twice in FOIL. I'm just going to do the short way. You'll find that you'll get the same thing, plus b to the 4. Then here minus a squared, sorry, a to the 4 minus 2a squared b squared plus b to the 4. Okay, so if you do the algebra over here, collect like terms, what you'll notice is this and this will cancel, this and this will cancel, and what you're left with is 4a squared b squared. Okay, so y squared is equal to that, but we need y. So we take the square root of both sides. So y is equal to plus or minus the square root of 4a squared b squared, which is equal to plus or minus 2ab. Okay. So remember, when you take a square root, you always have to do this plus or minus. I forget it often, but don't forget it. Okay. So we needed to decide, okay, what is our y? Is it going to be the positive or the negative one? And the thing is, if you look here, we're below the x-axis. So this is going to be negative 2ab. Okay. So I hope everyone's happy with that. So now if we do tan theta, we know tan theta is tan your exterior. It's y over x. Okay. So our y is negative 2ab. Remember, it comes from here, negative 2ab, over our x, which is over here, a squared minus b squared. Okay, and that was for 4 marks. All right. Now they say it is further given that a is 3 and b is 2. Solve for theta, where theta is an element of 0 to 720. Okay. So what we're going to do is we're just going to be rolling with this, and we're just going to substitute in our a and b's. Okay, so let me take this over for us over here, because we're going to need it. We're going to substitute in over here on the right. Okay, so what we're going to get then is tan theta is equal to minus 2, here's a, there's b, over a squared, that's 9 minus 2 squared, 4. Okay, so what we get at the top is 4 times 3 is negative 12, over 9 minus 4 is 5. Okay, so we get tan theta is negative 12 over 5. Okay, so what we're going to get is theta is equal to tan minus 1 of negative 12 over 5 plus k 180. Okay, for tan. And then Kes. So I'm curious, if you're watching this from Kes, please let me know. I'm curious. I could maybe shout you guys out in the next video. But yeah, so K is the element of integer. I normally always say Kes. So if we have any Kes boys, let me know. I can shout you guys out. But anyway, so there's 2 methods to do these general solutions. So I teach this method. I like to stick to one method. I think this one's the easier one, but if you do the other method, the graphical method, feel free to do that, but I won't show that one. Okay. But anyway, so we have this. So this is going to be our general solution. So let's put this in our calculator. Let me show you what we get when we do that. So we just say shift tan of negative 12 over 5. And that gives us negative 67,38, negative 67,38 degrees plus K180. Okay, we'll round to 1 decimal place in our final answers. Okay, but the thing is, this is the general solution. Here's our general solution, but they want a specific solution on this interval 0 to 720. Okay, so we're gonna have to plug in some K values to see where we fall in this interval. Okay, so theta is an element, and we're going to open our curly brackets and then plug in some K values and see what happens. Okay, we need to be careful though. I'll show you in a second. Okay, so we're going to get negative 67.38 plus K180. So obviously if we choose this value is not valid because it's to the left of the 0. It needs to be between 0 and 720. Okay, so let's see if we just say time plus 180, we get this answer over here, 112.62. Okay, you might be thinking, okay, yeah, this one works, but we need to be careful cos, okay, cos has to be positive and sine has to be negative. All right, we know from here. So 112, that's what we just got that answer, 112 comma or whatever it was, it falls in this quadrant. Okay, it falls in this quadrant, which is, we're not allowed to be, right? Because remember, we have to be in the 4th quadrant. we have to be down here. So we have to make sure our theta values are in the fourth quadrant. Okay, so the answer we just got was here, okay, which is not allowed. So we cannot write down this, this 112. This one's not valid, okay. So what we have to do is then try where our K is now 2. And we get this value over here, 292,62. Okay, this one is valid, okay, because it is in the fourth quadrant. Okay, 292,6, I believe it was. Yeah, 0.62. So we're reporting now to 1 decimal place. Okay, so be careful with that. Then let's now choose K is 3. The problem here, again, this solution is going to be in the second quadrant, which is not allowed, right? Because remember, we need to be in the fourth quadrant. Okay, so you'll see that this answer, if we minus 360 from this, you'll see that actually it's the same as that 112,62, which is not allowed because, again, second quadrant. We need to be in the fourth quadrant. Okay, so this one didn't work when K was 3. So when K is 4, you'll find that then this is valid. Okay, 652,6, 652,6 degrees. I should have degrees here. Okay, and I can close this off. So firstly, if I minus 360, you'll see that this answer is the same as this one. So it's in the fourth quadrant, which is allowed. Okay, so if I go now and I make my K 5, you'll see I fall outside of the 720. So this one, so we're just done with these two solutions. Okay, so this one you had to be a bit careful of, because yeah, it looked like that 112 is valid, but you have to go back and think about these conditions. Okay, so be careful with that. All right, now we're moving over to this problem over here. We need to simplify the following expression, so we only get one trig ratio of theta. Okay, one trig ratio. So it either just needs to be sine theta, sine theta, cos theta, or tan theta. Okay, so let's just take it step by step and convert one thing as we go. Okay, so half doesn't change, cos 90 plus theta. Okay, so these are the 90 pluses, so we know cos is going to change to sine. Okay, but let's analyze. Let's do our cos diagram again. All students take calculus. Okay, 90 plus theta, we are in this quadrant over here. Cos is negative in this quadrant. Okay, so this is going to change. It's going to be a negative. But then the cos changes to sine theta. Okay, minus sine theta does not change. All right, now let's have a think. Sine theta minus 90. What quadrant are we in, right? So a negative angle just means a clockwise rotation. All right, clockwise. So we are in this quadrant. Sine is negative in this quadrant. And then theta minus 90, that means the sine is going to change to a cos. Okay, I hope everyone's happy with that so far. Here at the bottom, we need to be careful. So with the square, what we can actually write that as is cos 180 minus theta all squared. The whole thing is squared. Okay, so cos 180 minus theta, what quadrant are we in there? So 180 minus theta means we're in this quadrant. Okay, so it doesn't change to sine because it's 180. So it becomes negative cos theta, but then the whole thing is squared. Okay, minus 2, that doesn't change, and then cos of negative theta. So remember, negative angle means that we are rotating clockwise. Okay, rotating clockwise. So negative theta means we're in this quadrant. Okay, but it's fine because cos is positive in that quadrant, and it doesn't change. So it just becomes positive cos theta. Okay, so I could put this in a bracket with a positive there, but let's not do that. Okay. Now we have this. So remember, also careful with the square. So this we can rewrite as cos theta plus 90 degrees all squared. All squared. So what's happening there is, what quadrant are we in? Let's ask ourselves that again. So we're in the second quadrant. We're over here. So cos is negative in this quadrant. Okay. Then we're doing theta plus 90. So that means cos is going to change to sine theta. but then don't forget that whole thing is squared. Okay, so let's keep rolling with this. So let's keep simplifying. So this is -1/2 sine theta, and then this becomes plus sine theta times cos theta over, this now becomes cos squared theta minus 2 cos theta plus sine squared theta. Okay, let's look for anything else we can simplify. At the top, looks like we can take out a common factor. Let's not do that just yet. But here at the bottom, we have this cos squared and this sine squared. So what that will give us is just 1, right? Because remember, cos squared theta plus sine squared theta is just 1. Okay, so yes, so that we can change. Okay, so we're going to get -1/2 sine theta plus sine theta times cos theta over 1 minus 2 cos theta. Okay, I'm going to start working over here. Okay, so the bottom denominator is going to be a bit of a guide. Okay, we want things to cancel at the top. Okay, and what we're going to do is we're going to try and make a bracket at the top that's going to cancel with the denominator. Okay, so I'm going to write the denominator first, 1 minus 2 cos theta. So we need to take a common factor out at the top that will leave us a bracket of 1 minus 2 cos theta at the top, because we know we need to cancel this because we want a single ratio. Okay, we want a single ratio. So what you'll see is if I take out just sine theta as a common factor at the top, what I'm going to get is -1/2 plus cos theta. Okay, and you see it's not, these brackets are not the same, so I can't cancel. So what we should realize is I actually have to take out a -1/2 sine theta, because what I'm left with then is this becomes a 1 if I take all of that out, minus 2 cos theta. Okay, because if I distribute this, what I'll get is +1 if I multiply those two together, which is what I had here, +1 in front. Okay, so what I'm left with now is these two brackets. Okay, these two brackets can cancel, this one and this one. So now I get -1/2 sine theta. And very important, 1 trig ratio. Okay, there we go. That's how you would do that one. So now we need to prove this identity. And whenever we prove identities, what I'd really recommend is choosing the most obvious simplification. Okay, so the things that are most obvious. So the things that you convert easily. So what I mean by that is, if I show you on the formula sheet, for example, this, if we have this. So if we have a cos 2 alpha, cos 2 theta, it's the same thing. You see how we have 3 conversions, right? So it's not obvious, it's not always immediately obvious which one of these we need to choose, right? Whereas if we have sine of 2 theta, there's only 1 conversion. Okay, so keep an eye out for that. Don't immediately rush into choosing one of these 3 if you are not sure for cos 2 theta. Okay, keep an eye out for that. It might come up in this problem, but it has come up before. Okay, I can't exactly remember this problem, but we'll see. Okay, we will see, but keep an eye out for that in the future. Okay, so anyways, let's work with the left-hand side. And remember, we can always use the right-hand side as a bit of a guide. Okay, so let's convert everything that is immediately obvious. Okay, so sine theta does not change. Tan theta is just going to be sine theta over cos theta. It's only got 1 sort of conversion over there. Okay, now let's write this as divide. Okay, it's just going to be neater. Otherwise, we're going to have fractions over fractions, and then there's going to be fractions there. Okay, so let's do this. So tan 2 theta is the same as just sine 2 theta over cos 2 theta, right? It's just normal tan. Okay. And then 1 minus, and here we have tan squared theta. So that's just the same as sine squared theta over cos squared theta. Okay. So here we go, right? So Now let's look what's obvious. So this is kind of what I was talking about before. So this has one way it can go, whereas this has three. Okay. So don't immediately choose one here. And what I'd recommend is don't even jump into this just yet, right? So let's try and make things smaller and simpler. Okay. If you expand this, it's going to get bigger. Okay. And it's not obvious what it's going to cancel with immediately. So let's deal with this thing. Let's make this smaller. And then also here we can put things together. Okay. So in our next step over here, we're going to get sine squared theta over cos theta divided by, this thing isn't going to change. Okay, we're not going to expand out immediately because we're not sure which one we need to choose. Okay, and then this, what we can do here to make this smaller, we can LCD. Okay, so we can have a LCD of cos squared theta, and what we're going to get then is this is going to become cos squared theta minus sine squared theta. Okay. So remember, our goal is to make things simpler for ourselves. Okay, so we try to make things smaller. This should look familiar. Okay, it is, I'll show it here again in screenshot. So it's on your formula sheet. You should be looking at these formulas on your formula sheet the whole time when you do these identities. You need to keep an eye out for these things, okay? Because this thing can become smaller by going that way. And you'll see in this case, we have this. You see how this thing in the bracket is the same thing as this thing here at the top. And then that can be converted to cos 2 theta. Okay, so we're making it smaller and easier for us to deal with. Okay, so this thing stays exactly the same. Let's not be hasty and expand anything out here. Not really that we can. And then this is sine 2 theta over cos 2 theta. All right, and then now this becomes 1 over cos 2 theta, cos squared theta rather. Okay, so now we can still make things, we can combine these two together, right? Okay, so what we're going to get then is this over here divided by, and now I'm just going to do a circle bracket, so I'm going to get sine 2 theta over cos 2 theta times by cos squared theta. Okay, so I made a mistake here. This is not 1. This is not 1. This is not 1. Okay, this thing, as I said, changes to cos 2 theta, cos 2 theta, and then these will cancel. Okay, sorry, I was confused. Cos squared theta plus sine squared theta is 1. Okay, that's not what we have. We have a minus. Okay, so then these two things cancel. Okay, so what happens is we don't actually have this at the bottom. We're going to have this cos squared theta. Okay, cool. I hope, sorry about that. Okay, I hope that is, you guys see what mistake I made there. Okay, now what we do is we're dividing by a fraction. So we're going to tip in times. Okay, I'm going to go over to a new slide for us. And I'll copy this over for reference for us. So it can go up here. Okay, so let's continue with this. So we're just going to tip in times now. So here's sine squared theta over cos theta times by, and we tip in times. Okay, so we inverse this fraction. Okay, now we want to cancel some things. So what you'll notice is this and this will cancel, and then we're just left with cos theta up here. And what we can do now is we can expand this out, right? Because it only has one expansion. And also remember, we can use the right-hand side as the guide. Okay, so we know we're going to need a sine theta at the top. Okay, so let us then do this. So we're going to get sine squared theta over, oh wait, here we have a cos theta. So I'll just write this over 1 times by cos theta over 2 sine theta cos theta. Okay, more cancelling can happen now, which is what we expected because the right hand side. So these will cancel, these will cancel, and then you're just left with the sine theta here at the top. And yeah, that is how we get sine theta over 2. So therefore, left hand side is equal to right hand side. So don't forget this, you do get a mark for it. Okay. And remember, this was our guide, so we need to make sure that this is what we get at the end. Okay, let me double check with the memo. Yes. Okay, so do not forget this step. You do get a mark. You do get a mark for that. Okay. Now let's move over to the next question. They say determine the general solution for the values of theta for which the identity is not valid. So not valid. And then write your answer as one single statement. Okay, this is important. Okay. So when it is not valid is when we're going to be dividing by 0. Okay, so when are we dividing by 0? When this thing is equal to 0 or this thing is equal to 0. Okay, so when tan 2 theta is equal to 0, that is the one case where the identity is not valid. So let us solve for this one. So we're going to get that 2 theta is equal to tan minus 1 of 0 degrees. Sorry, not degrees, 0, plus k times 180. And then obviously we got our k's. Yes, okay. So what we do now is we got this 2 in front, so we divide everything by, well, let me do this first. Let me put this in the calculator. So it's shift tan of 0, which is 0. Okay. So what I get is 0. So I'm not even going to write that. It's just k180. And I divide both sides by 2. So I get, because the also value of theta, not 2 theta. So that is just k times 90 degrees. Okay, so this is the first general solution. And then the other one comes from when this thing is equal to 0. Okay, so this is the first one. And then the second one comes from 1 minus tan squared theta is equal to 0. Okay, so what we get there is tan squared theta is equal to 1. And then tan theta is equal to plus or minus 1. Okay, because remember when you take the square root, so plus or minus the square root of 1. Okay, which is just plus or minus 1. Okay, don't forget that when you do square root is plus or minus. So what we actually have is two cases. Okay, we're going to have tan theta is equal to 1 or tan theta is equal to minus 1. Okay, and we're going to have two general solutions that come from this thing over here. Okay, so here we're going to get tan theta is equal to tan minus 1 of 1 plus k180. Okay, and then k's. And my z's are getting really messy. Okay, it's tough to draw double back sets. Okay, anyways, so we have that all, and then on this side we're going to get theta is equal to tan minus 1 of negative 1 plus k180. And then again, k is the element of integers. Okay, so if we work with this one, what we're going to get is, again, I'd use the calculator. I do shift tan of 1 is 45. So theta is equal to 45 degrees plus k180 degrees. And over here, I'm going to get theta is equal to, and then I just do minus 1, which is negative 45 degrees plus k180. Okay, so I currently have three general solutions, 1, 2, 3. I need to combine them as one single statement. Okay, so I need to look at these and see kind of what's the connection between these three. Okay, so let me look at this one. What are some possible specific solutions I can get in this one? Okay, so what I'm going to do is I'm going to choose some k values. Okay, let me see if I choose k as 0. 0 times 90 is obviously 0. Okay, if I choose k as 1, I get 90. K is 2, I'm going to get 180. K is 3 will be 270. Okay, so let me write down. So you don't have to show this. Don't show this over here. Okay, this is just for our thinking of how we can get it as a single solution. Okay, so some of the numbers I got was 0, 90, 180. 180 plus 90 was the 270. Okay, so that's what I get from this one. From this one, what I'm going to get is 45 degrees when k is 0. And then I'll also get 45 plus 180, which is 225. I'll also get 225. Okay, from this one, what I'll get is I'll get negative 45 plus 180, which is 135. And what I'll also get then is, if I say when my k is 2, 315. 315. Okay, but what you'll notice is if I write all of these solutions in ascending order, right? So I have 0 degrees. I'm not going to put the degree sign now because I'm lazy. 45, 90, what's the next one? 135, 180, 225, etc., right? So what you'll notice is these are stepping in 45 degrees, okay? And what you'll notice is you can try it. If I do the other way, I'm just going to be stepping in 45s. This would be negative 90, just in the other direction. Okay, so for a general solution, what I can have is just theta is equal to k45. Okay, because these are just multiples of 45. Okay, so, and then k is the element of integers. Okay, so yes, I can write this as one ratio, as a single statement. Sorry, not as a ratio. One general solution, one single statement over here. Okay, so that was a bit of a tough one. You needed to do some thinking behind that. But yes, everything kind of goes together in one statement like this. For question 10, they say that A, C, and D lie on the circle with center O. So obviously these are radii. AE and DE are tangents to the circle at A and D respectively. So we know that this is 90 and this is 90 because of tangent perpendicular to radius. And ACD is 68. So ACD, 68 degrees. Okay, they have not indicated this on the diagram, so make sure you put it. Okay, we're going to need that information. All right. Now they say, state with reasons. We have to prove that AODE, this thing over here, is a cyclic quad. Okay. So again, we know that these are equal. This is 90, this is 90. And you'll see immediately that these are opposite angles of cyclic quad, and 90 plus 90 is 180. So they're supplementary. Okay. So therefore it's a cyclic quad. Okay. So pretty easy. Let me just add the 68. We might need that. Oh, we're going to need it probably in the next question. But anyway, so we're going to say that A1 is equal to 90 degrees. And the reason is tangent perpendicular to radius. And we're also going to say that D3 is equal to 90 degrees for the same reason, tangent perpendicular to radius. And what we're going to say is A1 plus D3 is equal to 180 degrees. We can say, just say therefore, because 90 plus 90 is 180. And now we can say, well, therefore AODE is a cyclic quad. And the reason, we need to give a reason why it's a cyclic quad, is because the opposite angles are supplementary. Opposite angles are supplementary. Okay. All right. So you can't say here opposite angles of cyclic quad because you need to say that the opposite angles are supplementary, because we're proving that it's a cyclic quad. You can't use it. The reason, if you knew it was a cyclic quad, then the reason would be up angles of cyclic quad. But here you have to show that they're supplementary. Okay. Or you need to state that they're supplementary, the opposite angles. Okay. Next question. They say determine angle E. So they need this. Let's recap. This is equal to that. That's 90. That's 90. This is 68 degrees. And we now know that this big thing is a cyclic quad. Let me show you. We know now that this thing is a cyclic quad. Okay. One thing is, even if you couldn't do A, if you couldn't prove that it was a cyclic quad and you moved over to B, use the information that this is a cyclic quad. Okay. Because they basically tell you that it's a cyclic quad. Okay. Now, so we need to find E over here. Well, if we know O2, we can find E because we know that these two angles are supplementary. They add to 180. Okay. But we can find O2. Okay. Because O2 is angle at the center is double angle at circumference. Okay. So O2 is equal to 2 times 68 degrees, which is equal to, if I put in the calculator, 2 times 68 is 136 degrees. So I can say, well, oh, and the reason here is angle at center is equal to 2 times angle at circumference. Okay, so I can say therefore angle E is equal to, it's going to be 180 minus 136, which is 44 degrees. And the reason there is opposite angles of cyclic quad. Opposite angles of cyclic quad. Okay, not too bad for 4 marks. Now for question 11, they say the equation of circle with center C is this. Okay, so they give us this statement over here. They say AO, OB, and AB are tangents to the circle. So we have tangents, and B is the point 12, 0. Okay, so we know that if we draw a radius here, that'll be 90. We draw a radius here, that'll be 90, because these are tangents. And then also if we drop this, that will be 90. Okay, so that could be some useful information. And now they say determine the value of P. Okay, so we need to be working up here. All right, so let's just complete the square. Okay, let's complete the square over here, and to then find P, because P is somehow related to the radius. Okay, but what I would recommend is just jump into completing the square, because then you also find the center, which could be useful. Okay, so what I like to do is I like to put the x's together, okay, and the y's together. So we're going to get this y squared minus 4y, that's squared minus 4y plus P is equal to 0. Okay, then completing a square is actually quite easy. What we do is we just write x, keep the same sign, we half this, which is 6 squared, plus this now is y, keep that sign, half that, 2, square that, plus P. Now we say, what have we created? If we square negative 6, we get positive 36, but we didn't have that before. So we take away what we've created. Okay, very much the same as how we're going to take away this positive 4 that we've created. Okay, equal to 0. All right, so let's get all the constants to the right hand side. Okay, so that's going to be equal to 40 minus P. Okay, so but remember this whole thing here is our r squared. So let's try and see what our radius is. Okay, we need to find the radius. So let's look. C is the point 6, 2. Okay, it comes from here. Okay, so I know that this height over here is 2 units. Okay, because from here to there is 2 units. It comes from my y value. Okay, so I know my radius is equal to 2 units. Okay, so therefore I know that 40 minus P is equal to 2 squared, which is 4. So what I have is 40 minus P is equal to 4. So if I take that to the other side, I'm eventually going to get that P is 36. Okay, that is how I would get that. Okay, P is 36. All right, so let me keep the center over here as 6, 2. We might need that. Anything else? No, not really. Okay. Now they say determine the equation of AB. Show all your working. Okay. So we need to find the equation of the straight line. So to remember, to find the equation of a straight line, we need a gradient and a point. So we have a point on the line. It's B. Okay, B is 12, 0. The thing is, we need to now find the gradient of AB. The issue is we don't have a point here to work out the gradient. Okay, but we're dealing with analytical geometry, so we could perhaps use this where the gradient is equal to tan theta. Okay, we might be able to use inclination. All right, so if we have this angle, then we can work out the gradient, right? But also to find this angle in orange, what we can do is we can just work out this angle, right? And then we can do 180 minus to then get that part. Okay, so let's think how we can get this angle over here. So it's a bit tough immediately to get this angle, right? So let me also just drop this down here. So I know that this is 90. Okay. Then also very interesting, I know that this is it from, so this is 6. Okay. So I know that this distance is 6. The reason I know that 6 is from the x coordinate. So I know that this distance is 6, but then I also know that this is 6, because to go from 6 to 12 is obviously 6 units. Okay. So I know this distance over here, 6. Okay. So what I can do is I can construct like this. I can construct this. I can put C and B together. So then what I can do is I can find this little angle over here. Okay. By using trig, because I also know that this is 2. Okay. So I can use trig to find this. And then I'll deal with how to find that over there. Okay. But let me find this, and then I can find that, add them together to get this whole angle. Okay. But my main goal, remember, I'm thinking about inclination. Okay, so let's try this. So this thing over here, let's call this drop down D. Okay, let's call where we drop this. So let's again say that we've constructed radius CD. Okay, and so what we have is CD is perpendicular to OB. And the reason there is tangent perpendicular to radius. Okay, so we need to say that because we are using this 90 degrees. Okay, so now what we can do is we want to find this angle. Okay, so we have our adjacent and our opposite. So what we're going to do is we're going to say tan of angle CBD is equal to our opposite over our adjacent. Okay, so this angle here is CBD. Okay. So CBD, the angle is, we're just going to put this in our calculator. So if I open the calculator and I just do shift tan of 2 over 6, I get 18,4349. Okay, so the angle is 18,4349 degrees. Okay, so cool. I have this part over here. So now I just need to get this part over there. So let me maybe construct another radius, okay? Because constructing one radius worked for me nicely. Let me construct this, okay? And I know this is 90 again because AB is a tangent. All right. So let's see what I know now in this triangle over here. So I know this distance is 2. From C, let's call this E. Okay, we're constructing now CE. I know that this is 2 because this is a radius. All right. So I know that that is 90, and I want to find this angle over here. So I need one more side. I either need this side or EB. So what you notice is I can get CB quite easily. Okay, because I can do a distance formula between C and B. Okay, so let me write my construction. So let's say I construct CB, I construct CE, okay, and I have that CE is equal to, it's perpendicular to AB, and the reason there is tan perpendicular to radius, okay, and I know that CE is equal to 2 units because it's a radius, okay. I don't think I really need to state this. Let me just check. I know the memo did this differently. Let me just check with the memo. Yeah, the memo actually does this very differently. So let's not even worry about that, to be honest. The memo used similarity. I might go over what the memo did in a second. But anyways, let me erase this. I'm probably on the wrong screen. Yeah, okay. Anyways, so I have this. And now what I have to do is I need to work out distance CB. Okay. So that I use the distance formula. So what that's going to be is 12 minus 6 squared plus 0 minus 2 squared. 0 minus 2 squared. Okay. So if I do that, this is 6 squared plus 2 squared. So what that's 6 squared, 36 plus 4. So that is the square root of 40. So square root 40 units. Okay. So I know what CB is now over there. I'm going to squish it in square root 40. Okay, so let's work up here now. I need to find this angle over here, which is angle EBC. Okay, and the ratio I'm going to use is I have my opposite and my hypotenuse. Okay, so that's obviously sine. So sine of angle EBC is equal to my opposite 2 over my hypotenuse 40. Okay, so EBC is equal to, so I'm just going to use my calculator again, shift tan of 2 over square root 40. Okay, I made a mistake here. This should not be tan because I was dealing with sine. Okay, I made so many mistakes in this question when I did it the first time, first recording, and now I'm making mistakes again. More coffee is probably required. Sorry guys, it was a complete mess, even when I recorded on the weekend. It's a bit better now. But anyways, I get this 18,4349. Okay, so 18,4349 degrees. Okay, so now I have this entire angle over here, ABO. I have this ABO. Okay, so therefore angle ABO is equal to, it's just 2 times this thing over here, right? So it's just 2 times this answer, which is 36,8699. 36,8699 degrees. Okay, so now to do inclination, right? Remember, inclination we measure anti-clockwise from this x-axis over here, anti-clockwise. Okay, so to then find my gradient, okay, what I'm going to do is say, well, the gradient of AB is equal to tan of 180 degrees minus ABO. All right, so 180 minus this. Okay, so if I go to my calculator and I say 100, sorry, I should be saying tan 180 minus that answer I had there is negative 3 over 4. Okay, so my gradient is negative 3 over 4 units. Okay, which is brilliant. So now I remember they asked for the equation of AB, the line equation. So remember it comes, the equation is y equals mx plus c. So remember I need a gradient and I need a point. So now what I can do is just substitute in a point. So what I'm going to substitute is 12, 0. So I'm going to get 0 is equal to minus 3 over 4, 12 plus c. Okay, so my c is going to be equal to, and what I do is I just take this answer times by 12, which is negative 9, but remember that goes to the other side. So c is equal to 9. All right. Now, very important, don't forget you have to write the equation. They ask for the equation of AB. So we're going to say that that the equation of AB therefore is y is equal to negative 3 over 4 x plus 9. Okay, don't forget this, otherwise you will lose a mark. Okay, so yeah, the memo did it a different way. What they did, they also did inclination, but to find this angle over here, what they did is they actually did similar triangles. Okay, they proved that this triangle and this one were similar. Okay, for me it's not exactly obvious for that. I'd like to work out this angle, then that one, but yes, this is the main idea. Okay, and what especially important was this inclination. Okay, so I hope that made sense for you guys. But now we are not done with this question exactly, because now in C they say a second circle with center 0, 9 with point 2,3 that lies on the circumference is drawn on the same set of axes. Do the two circles intersect? Show all working. Okay, so we should remember from theory that if the distance between the centers, let me draw two circles. Let me explain with the diagram. So here's one circle, here's another circle. Okay, so let's call this radius 1 and radius 2. Okay, and let's call this center A and center B. Okay, so if we add the radii, the sum of radii will be r1 plus r2. R2. All right. But if you notice, the distance between the centers is going to be this distance over here. It's going to be essentially this. Okay, this is the distance AB, but you can see here that the distance between the centers is bigger than the sum of the radii. Okay, and if that is true, right, so the distance between centers, I'm going to abbreviate like this. If the distance between centers is greater than the sum of the radii, then they do not intersect. So we need to look at this. Okay, if it is smaller, then they will intersect. They will overlap. Okay, so obviously we need what? We need the distance between the centers, and we need the sum of the radii. Okay, so let's work out the distance between centers. So we can say that the distance between centers, okay, to work that out, what we're going to do is that's going to be, remember, so this center is 6, 2. Okay, so the center is going to be 6 minus 0 squared plus 2 minus 9 squared. Okay, so if we do that, that's 36. This is 7 squared, so 36 plus 49. So that gives us 85, which is approximately 9,2 units. Okay, I'll show you in the calculator. Okay, so if we do 6 squared plus 7 squared, it's root 85, which is approximately 9,2. So we need this approximately because we need to compare the distance between centers and the sum of the radii. Okay, it's a bit difficult to compare surds like this, so it's nice to have them as like normal numbers, okay, instead of square roots. Okay, now what we have to do is sum of radii. The problem is they haven't told us the radius over here, but we can do the radius by doing the distance formula between the center and this point on the circumference. Okay, so what we can do is for the second circle, what we can do is we can do the distance formula between here. Okay, so radius for second circle, we're just going to do distance formula. So that's going to be 0 minus 2 squared plus 9 minus 3 squared. Okay, so then the radius for this circle is going to be, that'll be 4 plus 6, so this will be square root 40. Square root 40 units. Okay. All right, so now let's do the sum of radii. Sum of radii, and that is equal to the square root of 40 plus 2. Okay, because remember the radius here was 2 units. Okay, so if we do that in the calculator, we get square root 40 plus 2. That's a weird number, so let's convert it to a decimal. 8,3. It's approximately 8,3. So approximately 8,3 units. Okay. So what we can say now is the distance between the centers is greater than the sum of the radii. So they do not intersect. Okay. So we can say they do not intersect. So they do not intersect, and then the reason here is because the distance between centers is greater than sum of radii, because distance between centers is greater than the sum of the radii. Sum of radii. Okay, so remember, don't abbreviate. Okay, don't abbreviate over there. Okay, cool. Now let's move over to question 12. This is where I got up until, and then I realized I had audio issues. Okay, so we're nearly done. 2 more questions, guys. So, circle with center O. Here's our center and diameter AOC. So here's our diameter. So obviously this is a radius, that's a radius. This is 90 degrees, angle in semicircle with chords AB and BC. They say chords AD and EC intersect at F with OF perpendicular to EC. Now they say AOC bisects BCE. Okay, so bisect comes from, so bi means 2 and sect means intersect. So 2 sections. Okay, 2 intersections. So, well, not 2 sections. Okay, so AOC cuts this angle into 2 sections. So BCE BCE is here. Okay, so these angles, if that's x, they're equal. C1 is equal to C2. They tell us over here. Important bit of information. Okay, don't forget that. All right, now they say we have to prove triangle ABC is similar. So this means similar to OFC. All right, so here's ABC. Okay, and OFC is here. OFC. All right, so remember this is 90 degrees. So we're going to say in triangle ABC and triangle OFC, what do we have? We have that angle B, so just call it ABC, is equal to 90 degrees, and the reason is angles in semicircle. And well, then we have that therefore ABC is equal to F1, which is equal to 90 degrees, and F1 is equal to 90, that was given. Okay, cool. Then also important, we have that C1 is equal to C2, and this was given. Okay, C1 is equal to C2. It came from this reason over here, given. Okay, so now we can say, well, therefore, what are we missing? O2 is equal to A2. So therefore, O2 is equal to A2. And the reason there's angles in a triangle, it's just the remaining angles. So therefore, triangle ABC is similar to triangle OFC. And then do not forget the reason. The reason is angle, angle, angle. Okay. All right. So there we go. So that was for this question. So we are probably going to use this information again. So do not forget this. Okay. Remember this. We're probably going to need it. Now they say determine the numerical value of BC and FC. Okay. So where's FC? It's over here. And where's BC? It's over here. Okay. And we just proved these triangles are similar. Okay. So let us have a look. Let's do some ratio. Here's BC. There's FC. Okay. So let's say that BC over FC, okay, is equal to. Now let's choose another ratio. So we have some options. We could choose AB and OF, but let's see, AB and OF, we don't really have any relation between those two sides. Okay. So can I get rid of that? Yeah, perfect. Okay. So let's see, how about if I do AC over OC? So AC, I'm going to erase some things over here. Here's AC, and here's OC. So what do I know between those two? Well, I know that AC is equal to double OC. And that's because OC is a radius, and AC is a diameter. Okay, so I'm going to choose those two, right? So it's going to be AC over OC. Okay, and then how do I know that these sides are in proportion? Where did I get that from? Well, I got it from a triangle ABC being similar to triangle OFC. Triangle OFC, which I just proved. Well, we just proved over here. Okay, so I have that, but now I need to say, well, AC is equal to 2OC, and the reason is radii. Okay, so we have that. So we're going to have then that BC over FC is equal to 2OC over OC. And what's going to happen is these are just going to cancel. So what you're going to have is BC over FC is equal to 2 over 1. So therefore, BC to FC is equal to 2 is to 1. Okay, because BC is double FC. Okay, now do not forget this piece of information either, because we might need it in the next part. Okay, now we get a bit of a hefty question for 7 marks, but they say hence, so we have to use information that we have proven before, we've shown before. Okay, they say prove that this thing is equal to this thing over here. Okay, so these things look weird, right? So let's see where they get these things. Where is all of this coming from? Okay, so let's have a look. So AC over 2. Okay, so Also, this looks like Pythag, right? Because you have two things squared minus each other. Okay, so let's see where this came from, right? So if you do Pythag in this big triangle over here, right? Remember, this is 90. So if you do it, you're going to get AC squared is equal to AB squared plus BC plus BC squared. Okay, but we're not dealing with that. We're dealing with AC over 2. Okay, we're dealing with AC over 2. Okay, but AC, we know that AC over 2, if we look at this and we look at OC. If we look at OC, we know that OC is a half of AC, right? So OC is AC over 2. So we need to think about where were we? Where did I get this AC over 2? And this AC over 2 is just OC, okay? And that kind of gives us a hint that we're working in this triangle over here. We're doing Pythag in this triangle, okay? So we know that AC, so rather we know that OC is equal to AC over 2. Okay, that's where this came from. Now let's think where they get AB over 2. AB over 2. Well, we can look over here, right? So here's AB. So AB must be related to OF. So AB and OF. Well, the thing is, what we can do is we know that AB over OF is equal to 1 over 2. Yes, is 1 over 2, right? And this came from similar triangles. It came from ABC, or it didn't came from similar, it came from sides in proportion. Okay, sides in proportion. Well, technically it did come from sides in proportion. It did come from, I'm pretty sure this is okay as well. ABC similar to, what was it? OFC. Where was it? OFC, yeah. Okay, because we had this ratio, right? So BC over FC is 2 over 1. Okay, so BC over FC is 2 over 1. So if I do it the other way, where I put, let me show you. So let me not erase that. So if I do BC, right, over FC, I get 2 over 1. We showed that over here. Okay, BC over FC is 2 over 1. So if I do it the opposite way, right, if I'm dealing with, in this case, AB over OF, so here's AB over OF, right? So I know that OF over AB is going to be 1 over 2. Okay, so I have the sides and proportional similar triangles, right? So what I have then is OF is equal to AB over 2. Okay, what I can do is when I cross multiply over there, I feel like something is wrong over here. It's meant to be other way around, sorry. It's meant to be OF over AB is 1 over 2. Okay, so then, yeah, when I cross multiply, yeah, essentially when I solve for OF, this AB goes up there. Okay, so I have this, OF is AB over 2. Okay, so I can rewrite this as OC squared minus OF squared. Okay, so if I'm just looking at the left-hand side, okay, yeah, so I can say, well, let's start off with, I have this. Okay, so what I can say, therefore, AC over 2 squared minus AB over 2 squared, that's, well, just equal to OC squared minus OF squared. Okay, but I know from Pythag that I have, if we look at in triangle OFC, right? If I look in that triangle, I know that I have, if I do OC minus OF, I know that FC squared is equal to OC squared minus OF squared. Okay, so I know now that this thing is actually just FC squared. Okay, because this thing here in the green box became this. Okay, it just became that. All right, I was on the wrong view there, sorry. Okay, it became this. Okay, and I know this is just FC squared. Okay, so I'm getting somewhere, right? So I need to show that FC squared is equal to DF and FA. So here's another connection that I need to make. What is the connection? We're kind of like investigators here. We need to find, okay, what's the connection between FC and this? Okay, so let me have a look. Let me have a look. Where's FC? Here's FC. Where is DF? DF is here. Where is FA? FA is here. Okay, so I need some connection with FA and DF. All right, so, and these things are multiplied. So this came from some similar triangle ratio. Okay, so I need this and this and this line. So essentially what this is all pointing to is I need some ratio with these sides, DF and FA and FC. I need to connect those. So what we should realize is I need to be working in these two triangles. I need to be proving that this triangle is similar to this triangle, this whole one. Okay, and it's actually not too bad to prove. Okay, what we're going to do is I'm going to work here. Okay, sorry, I went back. So what I'm going to do is now work in these two triangles. So I'm going to say, well, in triangle ACF, let me put triangle over here, and triangle, we need to think of how they relate. So A relates to E, so triangle E, and then C relates to D. Okay, so there's C, D, and then obviously the F's will correlate. Okay, so the way you write these is important. Okay, so in these two triangles, we have that A1 is equal to angle FED, and the reason there is angles in same segment. Okay, angles in same segment. Okay, and also we get that C1 is equal to angle FDE, and the reason also the same, angles in same seg. Okay, so what we have then is, well, we know that this angle F is going to be equal to that angle over there. Okay, so what I can write is, what angle is that? So I can write that CFA, angle CFA is equal, well, therefore CFA is equal to DFE, and that's because of interior angles of triangle, of a triangle. Okay, so now I know that these two triangles are similar. EDF. Okay, so if you're curious about why are we proving similar here, I hope hopefully things are about to click for you. Okay, now we need DF and FA and FC. Okay, so let's do FC and DF. Okay, oh, and the reason here is angle, angle, angle. I always forget my reasons. Okay, so let's do this ratio. Let's do FC. Okay, remember CF and FC are the same thing, is equal to DF, okay, over DF. And now I need something with FA. So FA comes in over here. Okay, so that's going to be equal to FA. Okay, so FA came from all the way around. So that's going to be EF. Okay, and the reason why this is important is if I cross multiply now, this is going to go up there, right? So let me show you. So this came from this reason over here. It's triangle ACF similar to EDF. Okay, that's why this ratio is true. Okay, so let us move to a new slide. Let's move to a new slide. Okay, so let me copy this, go to a new slide. So we have this. Okay, so what I'm going to do is cross multiply, because what I'm looking for again is this. I want to times DF and FA. And what I'll notice is if I put that up there, if I cross multiply, I will get that. Okay, So on the left, we have this FC times EF, okay, is equal to, and what order did they write it? DF times FA. Okay, DF times FA. All right, so have a look here. Do you see how we have this over here as well? DF times FA. I have this. Perfect. Now, my next issue is, what is going on here? Okay, I have my FC, because remember, what am I trying to prove? I'm trying to prove that FC is equal to this. So what's great is I have FC, but now EF. I need to get EF. I need to somehow show that EF is equal to FC. Okay, I need to somehow show that EF is equal to FC. So let's think about how I can do that. Okay, so here we have EF, and here is FC. So I need to somehow show that these two lines are equal to each other. So this is a big issue, okay? We need this equal to this. That's what we need. So have a careful look here. Maybe pause the video and think. It's not very, very obvious. It's a bit easy to miss, and I did miss this myself, okay? But if you look, we have this line from center is perpendicular to a chord. What does that mean? That means these things are equal. Okay, so, but, we can say but, and we know that FC is equal to EF. Why? Because line from center is, because the line from center is perpendicular to the chord. That means it bisects the chord. Okay, so therefore FC squared is equal to DF times FA. Okay, so we have that, but also, therefore, remember, because FC squared, we know that FC squared is equal to this, but this thing over here is equal to this. Okay, so therefore, left-hand side, or let's write that. Let's just write all of this. So, well, therefore, AC over 2 squared minus AB over 2 squared is equal to DF times FA. Okay. Cool. All right. So that is how you would tackle this problem. So again, it's kind of like we ran into some roadblocks, and we had to deal with it. Okay. But remember, this type of question comes up often, right? So you'll get a statement like this. Okay, and it looks very confusing in the beginning. Okay, but you see how we broke it down? We did some thinking, and we said, okay, where is this coming from? Where is this coming from, right? And we realized this came from Pythag. And then we looked, okay, which triangle is it coming from? It's coming from this triangle, okay? And then we worked with it and we realized, oh, that's just FC squared, okay? But then we think, okay, where is this coming from? DF and FA. So here's DF and there's FA. So we know we had to have some ratio to get this. It had to come from some ratio of sides. So we need to choose two triangles to be similar, to prove that they're similar. And we made the educated guess, right, that it's going to be these two triangles. Okay, this one here in orange and also this one here in orange. Okay, so we did that, right? So we proved that they were similar. Okay, and we got this ratio, which was perfect for us, right? We got the ratio, we cross-multiplied that up, and here we have DF and FA. Perfect. That's what we had here. Our next issue is, well, we need this to be FC squared. So we somehow need to show that FC is equal to EF. And then we look and we say, oh, okay, now I'm here, I'm in trouble. I need this equal to this. And then maybe even drawing this on your diagram that they are equal would show you and be like, okay, and you think hard, you say, and you fight through it. It's like, how are these equal? And then you can say, oh, but this is perpendicular. It's line from my center is perpendicular to a chord, so they're equal. And then everything just falls in place. Okay, so I hope you guys followed along there. Okay, so use the question as a clue. Okay, we often use that even when we prove trig identities. We use the right-hand side as a clue. Okay, so keep looking for these clues and putting things together. Okay, I know it's tough, but sometimes you try something, realize it doesn't work, and then you keep going until the thing just clicks. Okay, kind of like a Rubik's Cube or puzzle piece. You keep spinning and trying different combinations until it clicks. Okay, so sometimes you'll try one combination, it won't work, but keep trying. Okay, and keep thinking, why didn't this work? Okay, what information do I need? Which direction am I going? Why did this problem not lead me in the right direction? Okay, guys. So I know it is tough sometimes, but it does require some deep thinking. But the more you practice these problems, the more you get experienced in the sort of dealing with roadblocks. Okay, but it's also really important that you know your base theory. Okay, because obviously this was just a base theory concept. So if you didn't know this theory, then you were stuck from this point. Okay. All right, final question. Final question. Let us have a look. So they say in the diagram below, a house is in the shape of a prism with a triangular shaped roof with one side CN 10 meters. That's shown. They say vertical tree is growing at a point T in the garden. Here's point T. NCT is 65. That's given over here. So this is in the flat plane. Okay, this is a horizontal flat plane over here. And CNT is 69 degrees, and the angle of elevation of the top of the tree from C is 43.5. Okay, so that is if we draw a triangle like this. Okay, a vertical triangle that's straight up in front of us. Okay, so, and remember this is 90. Okay, and we know that this angle of elevation is 43.5. Okay, so I'll draw a clearer diagram of that in a second. You'll see. So only question here for 8 marks. Last question. So there's all our totals and stuff, but the whole question is for 8 marks. Is it possible for the tree to hit the house if it falls? Show all working. Okay. So this question has come up before in other past papers, a similar type of question. And what you'll realize is the shortest distance from the tree to the house is if this is 90 degrees. If this is 90 degrees. Okay, so I'll draw a top view. So we have this. This is CNT. So I'm looking at a top view down onto this triangle. Okay, so we have this. This angle here is 65 degrees, and this one is 69 degrees over here. Okay, and obviously we can work out this one by angles in a triangle if we need it. But anyways, the shortest distance from point T to the house will be 90 degrees. So it will be perpendicular. So it'll be this perpendicular distance. Okay. So obviously we need to know the height of the tree. Okay. Because let's say this distance here is 15 meters. Okay. The shortest distance from T to this point, I don't know, let's call it D. Okay. Let's say we work this out to be 15. If the tree is taller than 15, it will hit the house, right? Because remember, the tree is going to be here, it's going to topple over, fall. And if it's greater than 15, right? So let's say it was greater than 15, it's going to fall and hit the house. Okay. So what you notice there is, what's important is this is 90 degrees. So we're going to have to solve for that 15. And also we need to determine the height of the tree. So let's start off by determining the height of the tree. Okay. So to determine the height of the tree, it'll be best to look at the triangle from, it's tough to draw, but this way. Okay, the vertical triangle with the angle of elevation. Okay, so what that will be is this triangle over here. Okay, here's point T, here's point A, here's point C. Okay, so the angle of elevation, this triangle over here. Remember that angle of elevation is given here. So this is 43.5 degrees, and this is 90 degrees. Okay, because the tree here is vertical. Okay, so we need to determine this length over here, TA, okay, the height of the tree. We can call it H. Okay. So to work out the height, we need one side, okay? And what we can do is we can actually solve for CT, all right? And the way we can solve by CT is if we look at this triangle. So I'll draw the triangle for us. If we look down at this triangle over here, CNT, okay, CNT. Okay, so we know that this is 10 meters. We know that this is 65 degrees, and we know that this is 69 degrees. Okay, so we know that that's 10 meters. We need to solve for CT, okay, because we need it for this. Okay, so what we can do is we can do the sine rule. Okay, so we just need this angle T, right? So we can say that NTC is equal to, so what I'm doing is I'm doing 180 minus 69 minus 65. That gives me 46 degrees. Okay, so this is 46 degrees. So what I can do now is the sine rule. So what I'm going to be saying is CT over sine 69 is equal to 10 over sine 46 degrees. Okay, so CT is going to be equal to, I'll show it in the calculator, it's going to be equal to 10 over sine 46 times by sine 69. Okay, which is, let's do this 4 decimal places, 12,9783. 9783 meters. Okay, so we have that for CT. Okay, so we know now that this is 12,9783. Okay, so what we can do now, remember we're trying to solve for AT. Okay, so what we can say then is the height of tree, well, let's just call it, yeah, so let's just say the height of tree. If we do this ratio, we have our adjacent, we're trying to find our opposite, so we're doing tan. Okay, so we're doing tan. So let me just say that we were working in triangle NTC rather, over here. And now let's just say we're working in triangles CAT. Okay, so tan of 43,5 degrees is equal to height, let's call it tree height, our opposite over our adjacent, which is 12,9783. Okay, so the tree height is equal to, so in our calculator, what we're going to do is we take this thing and we times it by tan 43.5, and we get 3159 meters. Okay, now what we have to do is we need to solve for this perpendicular distance over here, this perpendicular distance. Okay, so let's think how we can do that. So this is not 90 degrees, sorry, that's 69 degrees over there. Okay, let me redraw this diagram so it's a bit clearer for us. Okay, more of a top view. Okay, so CN is like that. Here's T. Okay, so CN T. All right, so this is 69 degrees, and this one here is 65 degrees. Let me draw this perpendicular line over there. So this diagram should be bigger, but it is what it is. So we have that. Okay, so we need to work out this distance. Let's call this D. Okay, we need to work out this distance of dt. Okay, so we know this entire thing is 10, but if we have this length nt, then we'd be able to solve for dn. Okay, so yeah, let's see how we can solve nt. So the thing is, to solve nt, we know the whole thing here is 10. We can just use the sine rule again, right? So we can just use opposites like that. Okay, and then remember this whole angle was 46 degrees. 46 degrees. Okay, so I'm going to do the sine rule over there. So I'm working up here now. So what I'm going to say is nt over sine 65 degrees is equal to, which one can I use? I'll use 10 over sine 46 degrees. Okay, so I get nt is equal to, and I've been on the calculator view. Okay, I've been very bad about that. I know it, you can't always see my cursor, but anyways, so 10 over sine 46 times by sine 65 degrees. And that gives us 1259.92. 1259.92 meters. Okay, so what we can do now, remember we're trying to solve for dt. Okay, so to do that now, we know that this is 12,5992. Okay, so that's our hypotenuse if we look in triangle D and T. So let's say we're working in that triangle, in triangle D and T. We probably should have said that we constructed dt. We've constructed dt, and it is with CN perpendicular to dt. Okay, so these lines are perpendicular. Okay, so in triangle D and T, what we have is we're trying to find distance dt. Okay, so here's our angle, this is our opposite, this is our hypotenuse, so we're using sine. Okay, so sine of 69 is equal to our opposite, which is dt, over our hypotenuse, which is 12,5992. Okay, so dt is equal to, and I'm still in the calculator view, is this answer over here times by sine 69. Okay, so dt is 11,7623. 11,7623 meters. Okay, so this distance dt over here is 11,6323. Let me show you the memo's diagram. They drew it very nicely compared to what I did. Okay, so here is the memo's diagram. Okay, so this distance here, I call this d. So that distance over there is 11,7623. Okay, and the height of the tree is 12 meters 3159. Okay, so yeah, the tree will hit the house because dt is the shortest distance from this point to the house. It's the shortest point. The perpendicular distance will always be the shortest height. So the shortest distance. Okay, so the shortest distance is 11,76. Okay, and the tree is taller than this. Okay, so you need a conclusion because they ask, is it possible? And we need to say, yeah, it is. Therefore, the tree will hit the house. Okay, therefore, a tree will hit the house. Because if we kind of interpret this with maybe some easier numbers, again, let's say the shortest distance from this point, the base of the tree, to the house is 10 meters. Where did this come from? Oh, it's coming from below the diagram. Okay, anyways. So let's say that the shortest distance from this point to the base of the tree is 10 meters, from the house to the tree is 10 meters. But if the tree is 15 meters tall, and this is the shortest distance, obviously the tree is going to hit. Okay, that was the end of this paper. Okay, 450 marks. So this paper was a bit of a mess. I do apologize. I know I was in the calculator view for a long time. I mean, I'm probably still in the calculator view. I think I just changed it. But yes, sorry if it was a bit of a mess, and sorry if I know some of my explanations were maybe a bit wordy and a bit confusing, but always happy to clarify in the comments. But at the very least, I hope the video was helpful. And yes, I wish you guys all the best as always.